ওই যে হুক করে লাইন দিয়েছিল না, সন্ধ্যাবেলায় যে হাওয়াটা দিল না, হাওয়াটা দেওয়াতে ওই যে হুকের তারটা ওটা ছিঁড়া গেছে। ওই যে হুক মারের জিনিস ছিল লাইনটা।
Hello, everyone. Good evening. Okay. So today, I guess, is a lucky day. We got some extra time, right? A half an hour extra. Hello, I guess we can start. Others can join in the meanwhile. I guess few of like the students might not be aware of the change in time. I also got to know last minute, right? Okay. Anyways, we can start discussing and yeah. Okay. So first of all, right, I confirmed, right? There has been like all that I have a question spiral matrix. That's it. Not getting completed. It's a matrix to a spiral matrix, so there is an error in the test case, right? So that I already informed to that there's something wrong in the test case itself. Apart from that, other questions should be fine. Okay. So I had noted a few things in the like sheet where from where we can start. KMP. Okay. One thing KMP I discussed, right? So that's something which is there in going forward as well. So we'll see KP. If we get time today, we'll cover that. But my priority will be to first do a quick revision because this is our last session. So first is to do a quick revision and complete your doubts, right? Anything that's remaining on the questions, and then we can go for hard questions or any questions in particular that you want to solve. Okay. Hmm. Hmm. Okay. Well, let's start. Let me quickly share the screen. Hmm. Okay, so let's start with this question and see what the rest of this. This is an easy one. This is not a difficult question. So we already know and the entire logic for this, just that it's a different way to do so. Okay, so what the question is, let's say if I have to print all the prime numbers in a given range, right? So what you can do is you can take all the prime numbers in a given, like you can run two loops. One loop will run for I equals to 1 to n, which is like all the numbers, right? In any range, right? You have to print the prime numbers from the range 1 to n. You'll run the first loop from 1 to n. And the second loop would run from like 2 to square root of I, right? SQRTI, right? So this is how you will run the two loops and you will get the like you will basically find out the prime numbers, right? Now this is one way which is correct. You get the logic in n root n, which is optimized, which is fine. But there is another trick. If you want to use this prime numbers, if you want to get this prime numbers, you want to print them later, or you want to use them, or you want to check whether a number is prime or not in a given range, right? So what you can do is you can create an array of n size, okay? Not n plus 1. So that we also have n as the index in this array, right? So each index in the array represents a number, right? So 0 represents the number 0, 1 represents the number 1, 2 represents the number 2, and so on. Okay. So every index in this array is a representation of a number. Okay. Now what we have to do is we have to figure out okay. We have to figure out whether that number is prime or not. If it is prime, we will mark it like as prime. If it is not prime, we'll mark it as 0. So initially all the numbers are marked as 0. That means all the numbers are not prime. Okay. Initially I mark them as 0. That means all the numbers are yeah. Let's think in this way. Okay, so let's think it in this way. It would be easier to write it. So if a number is marked as 0, that means it is prime. And if it is marked as 1, that means it is not prime. Okay. So all the numbers are marked as initially 0. That means all the numbers are prime initially. Okay. Okay. We have considered all the numbers are prime. Now, which numbers are not prime that we know? So we know 0 is not prime. So let's mark it as 1. 1 is not prime. So let's mark it as 1. Okay. 2 is not prime. So let's mark 2 is also 1. And 3 is okay. Or let's do this for just okay. Let's do it for just two numbers. Okay. So 0 and 1. Okay. So now what we want to do is see. 2 is prime. We'll do that. We'll mark them. So let's say 0 and 1, which is non-prime. We'll mark them as 1, which is not prime. Okay. 2 is prime. Okay. So now all the other numbers in here are prime, right? 0 and 1 are not prime. 0 and 1 are not prime. For the criteria for any number to be prime is it should have exactly two factors. They don't have two factors, right? So they are not prime. Okay. So now for the remaining numbers, what we can do is we can start from 0 to n. Or this to root n. Okay. And what we can do is we can do over here is we can run a loop j, which will run for all the multiples of 2. So for example, we'll start with the first multiple of 2, that is, we'll start with 2i into 2, and we'll go until so let's start with 2. J starts with 2, and we'll go until j into I is less than equals to n, and we'll do j plus plus. Okay, yes, this makes sense. J. Oops, which is not done. I guess we are done. Okay. Yes. So, okay, let me tell you what I did over here. So let me explain you the logic. So think it of a number, like think of any number, right? Think of any number, which is the range for which we want to check whether all the numbers in that range is prime or not. Okay. So let's say we want to check all the numbers in the range of 1 to 15. Okay. Till 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So 15. So we have, okay, I'll explain, forget about this logic for a second. I'll explain this. Okay, just a second, look for what I'm trying to do. So initially I created arrays, all the values were 0. Right, I marked 2 values as 1 and the remaining values are simply 0. What does 0 mean? 0 means that they are prime, 1 means that they are not prime. Okay. 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 So 0 means that they are prime, 1 means that they are not prime. Okay. Now what we are doing is we are starting a loop from 2. And what I'm telling, any multiple of 2 is not prime. So let's mark it as 1. So what are the multiples of 2? So 2 is prime. Okay, forget about 2. So we'll start with 2 into 2. So is 2 into 2, we checked. J is starting from 2, right? So is 2 into 2 less than n? 2 into 2 is less than equals to 15. Yes, it is less than equals to 15. Okay. So we enter inside this, and 2 into 2 is 4. So we mark this as 1. So that means this is not prime. 4 is marked as 1. Yes, it has a factor 2. Okay. Now j increases, j becomes 3. Next iteration we check 3 into 2. Is 3 into 2? Well, let me write it in this way. I into j. Makes sense, right? So I into j, whether it is prime or not, right? So whether 2 into 2 was not prime. 2 into 3 is also not prime, right? So any multiple of 2 is not prime. So 2 into 3 is also not prime. So let's mark 2 into 3 as well, 1, because it is not prime. Okay. So we just mark 2 into 3 as non-prime. So we'll mark this as also not prime. Okay. This is also not prime. Next, we'll mark 8, which is again multiple of 2. So this is also not prime. 10 is a multiple of 2, not prime. 12 is a multiple of 2, not prime. 14 is a multiple of 2, it is not prime. So 2, 10, 12, 14. All of them are multiples of 2 and they are not prime. So we mark them as 1. Okay. So basically what we are trying to do is we pick the first non-prime, first prime number, that is 2. And we wrote all the multiples of 2 is not prime. So let's mark that as 1. Simple. Okay. Next iteration, we'll pick the number as this 3. And we'll mark all the multiples of 3 as non-prime. So the multiple of 3, first multiple of 3 is 6, which is marked as non-prime. Okay. Then we have 9. So 9 is also not prime. So let's mark 9. Then we'll mark 12. 12 is already marked, and we'll mark 15 as well. So we marked 9, 12 is marked, and then we'll mark 15, which is also not prime. Okay. Next, we got 4. So 4 has been marked, and any multiples of 4 would have been already marked, right? So what we can do is we can check this first before doing this. So if any number is marked as prime, if a of I is double equals to 1, that means this number is marked as prime. That means all its multiple will also have been marked as prime. Check for 4. Any multiple of 4 is marked as prime. Any multiple of 6 is marked as prime. Right? Any multiple of 8 would have been also marked as prime. because if this is marked as prime, that means we had a factor of it, and it's whatever factor 4 had, that is also going to be the factors of any multiple of 4. So 4's multiple is 8, so 2 is also a factor of 8. 4's multiple is 12, so 2 is also a factor of 12, right? So that's why all of them are already marked, so we don't have to check that. So if this is 0, then only we'll need to do this. Okay, if that is 0, then only we'll do it. Okay, we don't run it for 4. Okay, so the next number is 5. Okay, 5 is prime, it is marked as 0, so we enter. Then we mark all multiples of 5 as prime. So 5 multiple is 1, which is marked as prime, 15, which is marked as prime. Okay, if we had like 20, 25 or something, we would have checked. If that is not marked, we would have marked it. Okay. Next, okay, what's the square root of 15? It is, okay, square root of 15 is less than 4, right? So yeah, it's less than 4, so we won't even run for 5. We'll stop here. That's it. Now check all the numbers that are marked as 0 that are prime, and the numbers which are marked as 1 that are not prime. So this is prime, 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 this is prime. All the non-prime numbers are marked as 1. Yes. How many of you understood this, got some idea? How many of you didn't? Tell me. I'll explain this again. I know this requires some time to grasp it. No, yes. Okay, let me explain this again. See, the logic is very simple. What we are trying to do is, see, check this. So what we are trying to do is consider a number. Consider a list of numbers or a list or an array. Okay, let me draw it a little bit larger. 1, 2, 3, 4, 5, 6, 7, 8, 9. No. Okay. Let's write the numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, yesterday I told you one concept. How many of you remember? While solving the AJ number, I told you one thing, that any number, right? Any number which is not prime will definitely have a prime factor. And I also proved it, right? Any number which is non-prime always has a prime factor, right? Why any non-prime number always has a prime factor? Anyone remembers? Why any non-prime number has a prime factor? As a prime factor. इसको भी याद नहीं है. Consider this, like consider so consider any non-prime number, right? Consider any non-prime number. Let's say call it as 27. Okay. So what are the factors of 27? 1, 3, 9, 27. So you'll say, okay, let's forget about 1 and 3. So these are not prime numbers, right? But you can break any non-prime numbers to prime numbers, right? Your non-prime numbers, if any non-prime number has non-prime factors, those factors can again be broken down into prime factors, right? Or again into factors which will be non-prime, which will be prime, right? If they are non-prime, then it can again be broken down. Ultimately, it would be prime factor, and these would be factor of this number as well. Right? If this number is a factor of this, and this number is a factor of this, then this number is also a factor of this. So basically, what I'm saying is, if 3 is a factor of 9 and 9 is a factor of 27, that means 3 is also a factor of 27. So even though it has a non-prime factor, its non-prime factor will definitely have prime factors, and that is going to be a factor of the original number as well. Okay, so any non-prime number will have prime factors. Okay, okay. So now what I did, we tried to assume that all the numbers are prime apart from 0 and 1, right? 0 and 1 are non-prime. So let's mark them as 1. Apart from that, all the other numbers are prime. So they are marked as 0. Okay. So they are marked as 0. Let's assume by default they are 0. Okay. Now what I'm telling is, we are starting with 2 and we are checking if this number is prime. Yes, it is prime. We have not done anything to this, so this is prime. So any multiple of it is going to be non-prime, right? Any multiple of it is non-prime. Okay, 2 multiple is 4, 6, 8, 10, 12, 14. All these multiples are non-prime. Basically, 2 के tables में जो भी numbers आ गए, they are non-prime, so we have marked them as 1. So any non-prime, any multiple of 2 is non-prime. Similarly, any multiple of 3 is also non-prime. So 3's multiple is 6, 9, 12, 15. So these are also non-prime. Now 4's multiple is 8. So 4's multiple you don't even need to check because 4 is marked as a non-prime number. So if it is marked as non-prime, then its factor, whatever factor we found of it, it is definitely going to the factor of all the other numbers. So for example, we found 4's factor is 2. That's why marked is as non-prime number. So it 2 is also going to be the factor of all the numbers which are multiple of 4. So this, checking this is also again a waste of time. We don't even need to check the multiples of 4. We'll again find out the next prime number. Next prime number is say 5. So we'll mark all the multiples of 5 as non-prime. So 5 multiple is 10, 15. So we mark them as non-prime. Okay. We are done, right? We don't even need to check for that. And the numbers which are remaining with this value 0, they are the only prime numbers that we have. Now understood? So basically, and you don't even need to do it for 2-minute iterations. If you just do it for square root of iteration. Now remember, for any number till square root of n, you'll get at least one factor of it if it is non-prime. So for example, for 15, you will get at least one factor of it till square root of n if it is non-prime. That same logic, right? Same logic that we did earlier, right? You don't have to do anything after 5 because see the largest number you have in array is 15. So for 15, you will definitely find one factor till square root of n if it is not prime. If it is prime, you are not going to find out any factor if you run it after square root or anything, right? So, and any number smaller than 15, therefore them also this is true, right? For any number, you will find a factor, at least one factor till square root of n, right? So till square root of n, you will definitely find one factor for every number. So that's why you just need to run it till root n. Sorry, you just need to run it till root n, and you will get all the prime numbers. You don't even need to run it for more than that. So for that's why I'm running the first loop for root n, and then I'm checking whether it is prime or not. If it is prime, then I'm marking all its multiples as non-prime. That's it. And this is a simple logic, and this is known as sieve Aristophanes. Sieve of Aristophanes. Yes, we started a little bit early today. How many of you understood this? Yes, no. Clearly understood. Easy. I told, right? The name was only difficult. The logic is very simple. Right, so these are all the prime numbers. So the first logic is to this we already knew, right? For every non-prime number, yes, this algorithm is known as sieve of Aristophanes, right? So this is optimal, right? So the outer loop is running for order n. Inner loop runs for what's the complexity of this? This is root n. Inner loop is also, I guess, root n. Or no? Okay, let's check. Yeah, hello. Sorry, yeah. So see, the outer loop is root n, right? We have to find out just the complexity of inner loop. Now, what's the complexity of inner loop is, this is not an how many multiples of 2 would be there? Okay, let's try to do it in the naive way, right? I also forgot this, but yes, this is I into j. It's not I into I. If it were I into I, then it were root n, right? I guess kuch log mein aayega, I guess. Let's check this. So for like let's say n is 15, let's say n is 100, right? So how many iterations will it run if we have the final n is 100 for let's say a of I is 2. So for 2 it is going to run for 50 times, we'll have 50 multiples of it. Yes, for 3 it's going to run for 30. For 4 it's not going to run. For 5 it's going to be running for 20. So it is decreasing, right? I guess it is root n itself. It's not log root n. I guess it is log n over something. It is. Achha, it is n by 2 plus n by 3 plus n by 5 plus n by 7 plus n by 11, something like that. Yeah, this is the pattern that it is going to form, plus n by 13. Now I guess this is log n. Log of log n. I guess this is log of log n. This is not log n, this is log of log n. Okay, something like that, log of log n hoga. That n log of log n, that is for printing, right? If we print it, then it is n of. Okay, let's check, right? I forgot this. The complexity क्या होता था? That is log of log n. Okay. Okay, so this is okay, got it. So this is n log of log n. So this complexity is n if we take n common as, so this is like the series, right? 1 by 13 or something. So this is log of log. Okay, why I'm writing with white? Not even visible. So this thing is log of log n, and we have a n. So this is n log of log n, and the outer loop is square root of n, right? The outer loop is runs for square root of n. So this is n log of log n into square root of n. Something like that. That's कुछ आता है. Or okay. No. So this is n log of log n, not square root of n. This is not multiplied, right? This is not multiplied. Okay, so this is finally n log of log n. Let me explain why it is n log of log n. See. Okay, see, how many times totally this statement runs, right? This is the statement that is running. So this statement is running for n by 2 times for n equals to 2, right? For firstly a of I equals to 2, then it runs for n by 3, then n by 5, then n by 7, then n by 11, then n by 13, and so on, right? Okay, so if we take n as common, so this loop runs for 1 by 3, 1 by 5, 1 by 7, 1 by 11, and so on, right? Okay. If you try to find out this is log of log n. So the entire complexity is n log of log n, and this is very much better than n square root of n. Right. So this was the complexity that we are getting for checking whether n numbers are prime or not. And now we are getting n log of log n. So this is better than n square root of n. Right. Between root n and log n, which one is better? Between root n and log n, which one is better? Log is better, right? So we are getting n log of log n. So this n log of log n, this is better than square root of n. This takes less time than n square root of n. And if you look at it right in very detail, this is even a lot faster than the ones that we are doing, right? So we don't have any like order n loop, and this is the only time we run for 2 only. It is the only time we run for half n by 2. Apart from that, 3, 4, 3, 5, 7. That's like we run for selective values that are primes, right? We don't even run it for non-prime numbers. Square root is actually counted. See, it is okay. Now let me explain it. See, Acha, let's count how many times this is running. Okay, this statement कितने बार run हो रहा है? So for n equals to 100, let's take n equals to 100. How many times this loop will run? Let's say a of I is 2. A of I is 2, right? This is the first value for it, which it is going to run. For a of I equals to 2, how many times this is going to run? For I equals to 2, how many times this is going to run? जब I 2 होगा, so till when this condition is satisfied, I into 50, right? So this is going to run for 50 times. For 100, it is going to run for 30 times. For 3, right? I equals to 3, it is going to run for 30 times. I equals to 4, it is not going to run. I equals to 5, it is going to run for 20 times. So I can say basically simply for so it is running for n by 2 times for I equals to 2, n by 3 times for I equals to 3, n by 5 times for I equals to 5, n by 7 times for I equals to 7, and n by 11 times for I equals to 11, and n by 13 times for I equals to 13, right? So it is just running for prime numbers. Now if we check, so we have calculated all the iterations, right? We are finding out, so this is sum of all the iterations, right? Sum of all the iterations. These are the square root values for which you are running, right? These are the I values for which you are running. So we have already taken into account that square root wala thing. This thing is going to run for square root times, right? All the square root things we have tried to find out. Now I just did, okay, what's the sum of this? What is the sum of this that is going to come up, right? So this is 10 such numbers, right? So 10 such numbers, if you take 1 by 13 and so, still 10 numbers, right? So let's say 10 times, right? 10 items. So this sum is represented by simply log of log n. This is known as log of log n. If you, what is the sum of this series? If you try to look over internet, you'll get this. This is log of log n, and don't ask me how this is coming, how to prove this. Okay, I don't know, right? I don't even remember how to prove this, because you can look that up in the internet, and finally the complexity is coming out to be n log of log n. I'll tell you how to identify the time complexity of any code. For this one, it was like this, right? We figured this out, and then I looked for the series of this. What is the series sum looks like? So we already knew, right? One series we got 1 by 2 plus 1 by 3 plus 1 by 4. So 1 plus something like this, right? As 1 by 5 plus 1 by 6. So all these, so we thought, oh, we got this is nothing but 2, right? What is the sum of this series? Anyone remembers what is the sum of this series? 1 plus 1 by 2 plus 1 by 4 plus 1 by 5. This was 2, right? Why this was 2? Anyone? Any logic? So this was 2 because this sum is 1, and all this sum combined will make 1, right? All this sum combined will make 1. Why? Look, this is 0.5, this is 0.3, this is 0.3, this is 0.25, this is then it is 0.2, and so on. If you keep on adding them, you'll get a like very small 0.25, 0.5, 1 by 5, 0. It becomes very small, right? It goes to become very small, significantly small, and then it becomes 0.00 and something. So if you finally try to find out the sum, it will be in near, somewhere near 2. Okay, it won't exceed very much by 2. Okay. So same logic kind of thing. We found out a pattern. We just look what's the sum of series that's going to look like. So that we got is log of log n. So finally we are telling this entire logic's complexity is n log of log n. Okay. Now understood. Now if we form this, now what are the usage of this? What is one usage of this COP Restosthenes? Right? Where can we use it? So for example, later if you have to check any number is prime or not, you can simply check it one time. So now if I give you any number in the range of 1 to n, for whatever n we found this thing out. So for example, let's say n is equals to 100. Okay. So for n equals to 100, we found out what are the prime numbers. So if I have to check whether a number is prime or not, system.out.println, let's say I simply need to do that number, right? So if I want to check 34 is prime or not, I simply can check a of 34 whether it is prime or not, right? So it's telling 1, that means not prime. Let's check for 33 whether it is prime or not. So it should say 33 is prime by printing 0. 33, oh, 33 is not prime. Sorry, 33 is divisible by 11 and 3. Let's check 31. 31 I guess is prime, right? Yeah. So 31 is prime, so 31 will get 0. Yep. See. So now if you have to check any number in the range of 1 to n whether it is prime or not, so that you can do it. If you have to print it, then you can do a order and loop to print it. That is fine. You can again run an order and loop. The complexity is not going to change. It is going to be n log of log n. Understood? Clear? How much of you joined late and did not get any part of this? Okay. Only one question. Is this Shiva-Sustenance is only for prime? Yes, it is only for prime numbers, right? This is only prime numbers. So let me recap once, right? Let me recap once for those of you who joined late, right? See, the logic is very simple. So what I am doing is, what I am telling is every prime number, every non-prime number has a prime factor. Okay? This we told, right? Every non-prime number will definitely have a prime factor. Why? Because if consider 27. For 27, the non-prime, so consider 9. 9 is a factor of 27. So you'll say, okay, 9 is a factor of 27. It is prime, it is non-prime number. But 9 can be broken down into a prime factor, and this is also a factor of 27. So any non-prime factor of the number can be broken down into prime number, which will be the factor of the number. Okay. So 27 ka factor is 9, 9 ka factor is 3, and 3 is also a factor of 27. Right. Now, by this logic, what we can do is, let's say, we'll assume this. See, we create an array. Okay. Oh, sure. Let's create this. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. You can create it as long as you want, right? Now we assume that all of them are prime except 1 and 0, because 1 and 0 are not prime. So we mark them as 1 because they are not prime. Okay, so every number that is non-prime, that will mark as 1. Now all the other numbers are prime. Okay, we considered all the other numbers are prime. Now what we did was we started a loop from 2 to root n. I'll explain you why we are running till root n just in a second. So we are running a loop for 2 to root n, and we are telling any multiple of 2, right? So we are running this j loop is running for 2, and it is every time we are increasing j by 1 until we reach the end of array. When will we reach the end of array? When this multiple I into j will be greater than n. So we are checking for, basically first we are checking 2 into 2. So 2 into 2 is not prime. 2 into 3 is not prime. 2 into 4 is not prime. 2 into 5 is not prime. 2 into 6 is not prime. 2 into 7 is not prime. So basically every multiple of 2 is not prime. That's what we are marking them as 1, because 2 is a factor of them. So how can they be prime? If they have a prime factor which is 2, so they are non-prime. So we don't have to do anything. Just mark them as 1 because they are non-prime. Now similarly, next iteration will be checking for 3. So 3 is again a prime number. So we'll mark all the multiples of 3 as non-prime. So 3's multiple is 6, already marked as non-prime. 9 will be marked as non-prime. 15 will be marked as non-prime. 12 is already marked. Right. Next iteration 4 will not even run for 4. Right. So 15's root n is less than 4, like 3 point something, 3.9 something it would be. Right. So you'll not even check, and all the other remaining numbers, right, which we did not mark, they are prime. So basically 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime. Now, how did this come out to be correct? ये correct क्यों आया? Right? Why did it come out to be correct? So see, there are few reasons. First reason is every non-prime numbers will have a prime factor. So for all the for every prime number, we just marked all of its multiples as non-prime. Okay. So every time we found 2, so 2's all the multiples were marked as non-prime. 3's multiples were marked as non-prime. 5's, 7's, all their multiples were marked as non-prime. Okay. So every multiple of prime number were marked as non-prime because they had factors, right? The second thing is we ran this loop for root n. Still, why it was correct? Because for 15 we already know that if we want to check 15 is prime or not, we can simply run a loop till square root of n, and we'll be able to get at least one factor of 50. Remember that cofactor logic that we understood earlier, that for 15 there should be at least one factor of 15 in the range of 2 to root n for it to be non-prime, right? Otherwise, if it doesn't have any factor in the range of 2 to root n, it will be prime, right? Yes. So, and yes, so if it has at least one factor in this range, the prime factor will be here. Right? So the prime factor will definitely be in this range, right? So it would definitely have a if it has any factor, be it prime, non-prime, it will be over here. Right? It should have one factor in this range. So for that, if we just run till root n, so we'll be able to get all the multiples, right? So for 15 and for 14, for 13, for every number, we'll definitely get one factor if there is factors of this number, if it is non-prime. If it is prime, we'll not get till root n, and even though you run it for n, you won't get factors for them, right? So that's why this logic is working, and this logic is known as CBOP Eratosthenes, which is basically we are using order and space to find out the prime numbers in a given range. The complexity of this logic is log n log of log n. Okay, understood? And space complexity is order n. Clear doubts? Okay, now tell me, is the algorithm difficult, or you all just the name was difficult? Is the algorithm actually difficult, or just the name was sounding so difficult? We knew everything, right? It's just that we have put everything, all of our logic, so that we created a new. Complexity में पहले n क्यों है? Many variations of prime cube. So this इसका sum है ना? ये complexity is just sum of the series, right? N by 11. So n को common लेके we just found out this. So इसका sum तो log of log n है. The sum of this is log of log n, but we also have a order n, right? ये तो multiply हो रहा है ना. Right? So that's why it is n log of log n. Okay. No, KMP is not used for finding prime number. That is for KMP is a string matching algorithm. वो prime number का algorithm नहीं है. That is a string matching algorithm. Square root time चल रहा है, but the square ये वाला iteration check करो ना. Total number of iterations कितने होते हैं? How do we find out complexity? We count the total number of times the loop is running, right? If we don't get any idea how many times this statement is running, that is our complexity. How many times this statement is running? For I equals to 2, this is running for n by 2 times. For I equals to 3, it is running for n by 3 times. I equals to 5, it is running for n by 5 times, and so on. Right? So that is where our complexity is coming out to be. Right, where we are getting n log of log n. If you just try to sum up, right, 100 के लिए sum up कर लो, you will get the number. So for example, 100 के लिए we are running this loop for 50, then for 3 is 30, for 5 it's 20, for 7 it's going to be 10, 30, 14 times, for 8 it's going to be 10, 12 times, for 9, and if you just add all of them, you will get somewhere near n log of log n. See, it is greater than n, right? N से तो ज़्यादा है. 50, 18, 90, 100, 120, 126. So already we have reached 126 iterations. Then we have for 8 के लिए कितना हो? 8 के लिए 12 है. 9 के लिए it's going to be 11, and 10 के लिए it's going to be 10. Okay, so it's 126, 137, 147 times. So it is running for 147 times. अच्छा, it is 33. हाँ, 33 होगा. So 150 times approximately. ठीक है? So we are running this loop for 150 times approximately for n equals to 100. Right? Now similarly check for 200, 500, and this is like n log of log n. It is telling this value is nothing but n log of log n. Let's put this. So 100 into log of log 100. So ठीक है, log 100 क्या होगा? Base 2, right? So it is base 2. I'm assuming it is base 2. Base 2 ही है ना? हाँ, base 2 होगा, I guess so. It is going to be 2 to the power 5, 6, something like that. 6 नहीं, 2 नहीं होगा. There would be something, some other base, right? Base 2 नहीं होगा. It might be a different base, I guess so. The base might be different, not 2. Base कुछ और होगा. 3, 5 or something होगा, something like that. And it might be related to n as well. Yes, might be related to n depending on what we are running this log, right? So कुछ different base होगा, and if you find out this log 100 of, no, it's not 10. अगर 10 होगा, this would be 2, and then for 10 this would be 0 point something, which should not be there, right? This product will come out to be something like 150. Accordingly, the base would be there. Okay, now you all figure out 1 point something होगा, वैसा कुछ होगा. 1 point something नहीं होगा, I guess 4, 5 के range में होगा something. Might be it is in a range of 1 to 10 or something like that. Okay. Okay. So now you can, that is like from mathematical calculation, how they got it is log of log n. You can figure that out. Check that logic. I understand, I'm not remember the logic, but I remember that this is like the best algorithm to find out CWAP restaurant, which is like simple, right? You don't have to remember this algorithm. You all know all the things. Square root, you all know. If you just simple thing is if you cancel out all the multiples of prime numbers, so they are not prime, right? So you just cancel them out, and the remaining array is prime. Just a second. Okay, understood. String addition for two strings, but to three values, but for array of strings, just a second. But for array of strings, we took it in order and that's something. For string, in order to like you cannot do it in like order and the concatenation would be order and right. So you won't be able to get it. You can use string builder and find out that right string builder find out the you have to do append at the end, not at the start. Okay. Okay, I got it. So basically, yes, the question that you told yesterday, see what you can do is, so let's say these are the two numbers representing the number, right? 2, 3, 4, and this is the number, let's say 5, 6, 7. Okay. So you have to add these two numbers. So firstly, you will add the last two characters. So 4 plus 8, 4 plus 2. So you can add these two. So you will get it as 6. And the next number that you get, right? 8 plus 3. 8 plus 3 is 11. You put 1. You append it at the end, not yes, you'll append it at the last, that is towards the right, not towards the left. Because adding it at the last is O1 operation, but adding it at the left is ON. Right. So this is O1, but this is ON. Okay. So you can append it at the end and you can get the result in reverse, right? So you get is 9 plus 1, 10, 6 plus 1, 7, and then 6. So this is your value. But now after you get this, you reverse this result. Yes. That is going to be same complexity that you got for array of this. KMP will require some time to understand. That KMP is yes. So let's see, right? Let me do a quick revision. Then I'll at the end if we get time, we'll start with KMP. This was easy, so I covered it. Don't worry, KMP is there, right? KMP, Robin Carp, all these things are there in detail. Robin Carp will not be here, right? Because that also has some usage of hashing. So before that, you'll learn hashing and then only you'll learn that logic. Okay, let's see the others one. Okay, let me quickly go through the revision, right? So today, let's do the revision actually. Okay, first of all, let's start with this. Let's see the questions. You have all the other portals to use for the review, for the questions, but you won't get a revision, right? No doubt session is going to recap all these things that we have covered, right? So this is going to be helpful for your interview. So listen to next 30 minutes, 40 minutes, very carefully, because we are going to touch everything that we covered, and this is going to be super helpful for your interview, right? How many modules? I guess total 3 to 4. 3 is there. 3 is definitely there. The fourth one was optional. I'm not sure whether now fourth is there. Fourth is also there. Fourth is an optional one, but it's a hard module, right? If you like it, you can continue for the fourth module as well. Okay, let's start from here, right? So we started with understanding basics of programming. We saw how println works, what are data types, what are variables, what are primitive, non-primitive data types, right? We understood a lot about non-primitive data types specifically. Now we know what are non-primitive data types, why we call them, right? What is the difference between primitive and non-primitive data types? So majorly this non-primitive or reference data type are stored in the heap section. They are like on-demand memory. We can get this memory on the runtime of the code. We cannot have any runtime memory allocation to any of these variables. They are like static memory. They are created in the compile time. They are getting space allocated in the compile time, and we cannot. So you cannot create int a equals to new int, right? That doesn't work, right? Int, float, long. You cannot create these variables in the runtime. All those variables are created in the compile time itself, right? They know their memory, they are already reserved in the compile time. And that's why they are known as primitive fundamental types, and these are known as reference types, right? We can do a lot of things with this strings, arrays, object, but these operations are costly. These are operations are, okay, I'll go slow. Okay. So we can do a lot of things with this reference types, right? These operations are costly, but this gives us a lot of flexibility and control over memory, right? So if you want to use the memory during running the code, we can use arrays, strings, or objects, right? Later, you're going to learn about object type, and basically anything like array list is an object. You'll still learn about hash sets, hash maps, lists, stacks, queues, all of them are nothing but object type, right? So all such things are known as object types, right? So they are basically object type, and again they are reference data types. I gave you the idea of array list, right? So array list, what is array list? It is nothing but array, but just that we have built something on the top of array. We have used array in a certain way so that we get, like, we can add numbers into the end. We can create an infinite size array. We don't need to tell the size at the starting, right? We can delete something from between, we can insert something in between. All those things are possible, which were not possible in array, right? How did we do it? We did not violate any memory law, like we are not creating a new memory and inserting it, but we are just using the array in such a way that we will be able to achieve insertion at end, or deletion from between, or something like that, right? Next, we saw the sizes of all these primitive types, right? So in the primitive types, we saw what's the sizes, like integer, byte, long, float, double, boolean. We saw all the sizes of this, and we also later used, right, what are the sizes. So how is this helpful, right? So for example, if we require a long large number, then we can use long. If we don't require it, we are happy with integer, right? If we require a, like, let's say, large decimal number, we can use double. Otherwise, we are happy with float or something, right? Then we came to know about default data type. So every number or every data type has a default data type. So numbers default type is integer, decimals default type is double, right? So what is the use of it, or what is the advantage of it? So see, so default data type basically tells us if we write a value, right? If you don't tell what type of value is it or something, it will automatically able to get which data type it has to store it. So for example, if I write a number, it automatically is integer type. If I write a decimal number, it by automatically it is a double type, right? So if we have to create a large number, this will automatically be an integer type. We have to mark L at the end of it to tell it is a long number. Same goes for decimal number. We have to mark F at the end of it to tell it as a float number. Otherwise, by default, it's going to be double, right? We also came to know about escape sequence, basically the characters that we can use to that we cannot add directly in the string or in the character, right? We cannot store it in character literal. We can use escape sequence to store them. So for example, double quote, /n, /t, slash single quote, forward slash, all these characters we cannot add into the double quote or a character. So we can use escape sequence to store them. For example, this, right? This can store a forward slash. If you put forward slash single quote, you will be able to store a single quote as well, right? So this will be able to store a single quote, which you won't be able to store in a normal string, character, right? Okay. Next, we learned about conversion. So this is very important, right? This is super useful. Conversion helps you to convert any data type from one to another, and you need this in a lot of things. For example, you have integer variable, you want to perform a decimal calculation. You have, let's say, a character variable, you want to store it in string, or you want to convert a integer to string. So a lot of them are implicit. A lot of them we do forcefully using forceful conversion, like explicit conversion. So we saw order like integer to long, long to float, and float to double. All these conversions are implicit, but the reverse is not possible. Reverse of it is explicit conversion. This is the easiest way to remember this, right? Okay. So now we saw this examples, right? We saw the example, what can be converted, what couldn't be converted. Okay. And then we saw if you want to print a certain number of decimal digits after in a decimal number, how we can do it, right? So percentage, 6F, and so on. Long to float is not a loss. This is the only exception scenario which I covered, right? So this is the only exception scenario where there is, so this is loss making, but this is implicit, right? This is the only example of loss making implicit conversion. So basically implicit conversion doesn't allow you to perform a loss making conversion. So for example, let's say we have long as this. This is a long number and we store it in a float. So by default, the size of long is 8 and float is 4, right? So we can do it implicitly as well. It doesn't throw errors that this is like a wrong conversion, but it loses data. Okay. I also gave this as example. Oh, well. See. So now it is converting, but this is loss of data. I would say, how is this loss of data? See, this is actually a loss of data. E12 means 10 to the power 12. Okay, so this is how you see it in calculators as well. Right, so it simply means 1.67273735 into 10 to the power 12. Right. So if you multiply it by 10 to the power 12, you'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So see, you're getting 4 zeros at the end. In actual number you had, you knew what are these places, right? 3, 7, up till 3, 7 it was correct, and from here it is wrong, right? From here the data became wrong, and like at the end you don't even have any data. All these digits were lost and you have zeros in place of this digit. So this is a pure case of data loss scenario. Okay. So this is the only implicit conversions which results in data loss. You can remember this as an example. If you are asked to give an example of implicit conversion which will result in data loss, it is long to float. Okay. We understood this, then we saw, okay, how can we print up to 6 decimal places or any number of decimal places? We saw we can use printf, we can use string dot format, and like we have different ways, right? So these are the two most commonly used ones. You can use any one of them, right? String dot format is better because you can add you can add it to the existing println. You don't need to write any printf or something, and you can just basically add any concatenate strings or all those things also work fine over here. Then you have rules for naming variables, right? There are certain set of rules that you need to follow while giving names to your variables. Like it cannot be keyword. You can have alphabet, digits, or special characters, but you are not allowed to use any special character apart from underscore and dollar sign. Dollar sign is something which we should avoid, right? You should avoid the dollar sign. But special character, digits, or alphabets is fine, right? You should not start with an alphabet or an underscore. It can be of any length, right? There cannot be two variables with same name in the same scope. Or we also covered what scope is, right? So any pair of parentheses or any pair of curly brackets is known as scope. It can be a scope of if condition, loops, or a normal scope, right? Like this. So here we have two different variables. So this is like error, right? If you try to run both of them, so this would give you error that A is already defined and we are trying to define A over here. Okay. See, A variable is already defined and we are trying to define A over here. So this is error. But if we do this, this is not an error. Because what is happening here is, firstly, this block is running, which is basically printing 15, and then when this block ends, this A variable dies out. So now there is no A variable in memory, right, in the outer block, and this A variable can be created. If you have these two variables in over here, this will throw you error because you are having two variables within the same scope. Right? We saw examples like this. You can take dollar sign as a variable, but this is something which you should avoid. This is allowed in the language, but you should not take dollar sign. Two reasons I give you. The reason is, first reason is it is not allowed in any other programming language. So it becomes problematic if you start using dollars in a program and the other developers are not using it. Second thing is it doesn't look, it looks like a special symbol, not a variable. So you should avoid it. There are a lot of other meanings associated with dollar sign in things like bash, scripting, and other languages, right? Where it is like treated as a variable annotator. So we should not use this. Okay. So if, like in gist, you should avoid this at all costs. Okay. Then we understood about increment and decrement operator. Basically, we have arithmetic. Okay. We have operators, which are basically symbols to perform operations. We understood about arithmetic operators, the operator which perform plus, minus, into, divide, and so on. Right. We understood, okay, these are arithmetic operators, and there is one arithmetic operators which actually works on string as well, which is addition. We gave this name to this operation of adding two strings known as string concatenation. Basically, joining of two strings one after another. We learned how we can take input using scanner, right? So we have different functions in scanner that we can use to take input of every data type that we want, right? We understood about relational operator, which is used to find relation between two variables or values. That this checks whether two variables values are greater than, less than, greater than, equals to, less than, equals to, or something like that, right? Then we understood about logical operators, where we are checking whether like two relational operations equate to true, false, or like what is the and or not result of it. So that we checked over here. Okay. Now we used like double equals to and single equals to, which is again like we compared them. So this is a like relational operator. This is a assignment operator, right? So this compares two values. This assigns a value to a variable, which is very much different, right? We understood about conditionals. We understood about if else nested if else ladder. We understood about multiple conditional logic of how what we can do with if else things, how we can combine if else and relational logical operator to create complicated nested conditions, right? We also saw the order of execution here that follows is not and then or. If you don't have brackets, right? If you have bracket, that will override any existing order that was present, right? Okay. I guess am I going too fast in covering this? Oh no. Yes. Acha. This is the easy part, right? That's why I'm going fast. I'm assuming you all will be able to like quickly grasp this. Correct speed. Okay, so I'll slow down as we progress to the like harder concepts where in memory or array list or something. Okay. Now we saw variations of if else programming, right? How we can write if else logic. And then we did the leap year question. Now this question is very important because I showed you multiple ways to do it. Basically, you can use ternary. You can use ternary operator to do it. You can use relational operators to do it. You can use nested if else logic to do it. And this is like a very good practice of practicing nested logic, relational operator or ternary operator, how you would write. Like now, what is the correct way to write logic? So there is no correct way until you are writing, until your logic is making sense, until it is easy to read and it is correct, it's fine, right? So before, right, it should be simple, it should be easy to understand, and it should be easy to read. Here, the ternary one is very difficult to understand, super difficult. So I would say don't go with this one. That never. Like logical and nested ones were at least like a little bit easier to understand as compared to the ternary logic. Okay. Then we understood like the most asked question in if else, like in interviews, you would see this question, which is known as tangling else. What is this tangling else question? So basically, if you have like a if else condition that runs in such a way that you don't have brackets, right? So if you don't have brackets, where will this else belong? Right. So here, since you have only one if, it will belong to this if. Now, to which else if this else would belong? Will it belong to the innermost if or the outermost if? So it would always belong to its nearest if, that is the innermost if, right? So it will always try to associate itself with the very first if it's a. Now, if you have two else, the first else will get associated with this if, and the second else will get associated with the outer if. And this case is known as dangling else. So, for example, so this is not the dangling else case. This is the dangling else where you have one else with which if this else would be associated, the inner one or the outer one. It gets associated with the inner one. Okay. And this case of else where which looks like it can be a part of both the ifs or either one. So it is known as a dangling else case. Okay. Next, we saw the largest, like we found out the largest number among three. Here I gave you like one thing to keep in mind is you have to put this equal to sign. Otherwise, this is an error, right? If you don't have this equals to sign, or when A and B and C are equal, they can be equal. You might get an error result, or you might see a wrong output, right? We also saw this how we can do it right for equal scenario if we want to handle it separately for great largest one. If they are equal, we want to print A and B is largest. If A and C is equal, we want to print that is largest. Otherwise, we want to print B and C is largest. Otherwise, all are equal. That also we want to print, right? So if you have to print it, we'll just increase the number of conditions for 4 variables. The number of condition is going to increase even further. We understood about ternary operator. This is basically a shortcut way to write if else conditionals. If you have like just a small conditional to write, if you just have to check if A is greater than 10, print greater or lesser or something. So you can use this, which is like to check small conditions, small assignments, small printing. So ternary is basically for this, right? It is not developed to write complicated logic. Ternary is developed to write simple logic as like this. Okay. Next, we learned about this, where we are basically comparing two values variables, uh, like which one is greater, largest one. Again, by using ternary operator. Three, we are finding largest among three using ternary. And yeah, that's it. Next, we learned about switch case, right? So this is it about conditions. Achha, any doubts still here? Normal variables, data types, assignment, relational operator, logical operators, ternary conditions, anything? Ternary. Okay. See, ternary mein what we do is we have a condition. If this condition is true, we run the expression one. If this condition is false, we run the expression two. Simple. Okay. देखो तो यहाँ पे क्या करा हमने if this condition, so let's say this is the if else condition, right? If a is greater than 5, put b is equal to 10, otherwise b equals to 15, right? So what we can do, we can do the same thing using this. If a is greater than 5, then put b is equal to 10, otherwise b equals to 15, right? Now we can write it in a single line. We don't have to write it in this way. This is also doing the same work. This is also doing the same work. If the condition is true, we run the first part, otherwise we run the second part. So this is can be used in assignment like this. This can be used to directly print values like this. Okay, and so on. So this is what ternary operator is, and this is what conditional is. Now the last type of conditionals was switch case. So there is nothing too much in switch case. It's just basically comparison between a value that you're writing over here in switch and all the cases that you have created. So you can create multiple cases. It will compare it with them. Whichever one becomes equal, it will run that, and it once it hits the break, it will break it. Okay. Now there is like so what to note over here. So there are two situations. One is like use of final. So all these variables that you're using over here, if they either has to be constant value, either you write 1, 2, or 3, something like that, which are constant, or you if you are putting them variable, those variable needs to be marked as final. Okay. So either you put constant values or you mark the variable as final. So final basically makes the variable value as constant. You cannot update any variable that is marked as final. So you cannot update, write x is equals to 5 over here. This will not allow this operation because x is marked as final. Okay. So either you put constant variables or the constant values. In case of case, this is the first thing. Okay. Second thing is in there is a situation known as fall through. Basically, if you don't write breaks in between of these conditions, what would happen is it would essentially run all the cases until it hits a break. So for example, if I write this, remove this break, and the first case is true, case one is true, so it will run this statement as well until it hits this break. Okay. Why this would happen? This would happen because it did not see any break in between and it will run it. This situation is known as fall through situation, where we were basically running all the conditions of this, all the multiple conditions in switch until you hit a break. Right? If one of them is true, you run all the other conditions until you see a break in between that will stop. So what is the use of this? So this helps you write conditions like this. So for example, if you write conditions like this, here you can take fall throughs advantage. So for example, if you want to run multiple statements based on multiple conditions, so you can use fall through. So for example, if case 2, case 5, or case 10, any one of them satisfies A, say if either A value is 2, 5, or 10, will run all these statements and will break, right? So this is the like advantage of fall through. You can run multiple statements uh, by by comparing with these cases, okay, and it would work fine, right? And we would break if none of them is true, then we simply go to compare case 3 as normal, right? It allows us to do this. Understood? Case fall through constants. Any doubts over here? Okay, let's take the other cases. So we have like your now we can take user inputs, we can do perform operations, we can write conditions, we understood everything. Next, we understood about increment decrement operator. This allows us to increase or decrease the value of any particular variable by one. Right. So there can be like very tricky scenarios like this where we can use multiple increment and decrement operators. We have to carefully figure out what's the final value that's going to come from here and how those values are going to get added. Right, because that would vary from how we have taken this value. Okay. Next, we learned about loop. Loop is fairly simple. Right now, we have used loops a lot of times. I guess now this would have been easy. Right. See, initially when we started, we were running it for the first time. So we had to use the cycle ICVU cycle. Now you run this cycle automatically, right? You don't have, you automatically figure out that this is how the loops run, right? So this is it, right? So then we ran the loops in the cycle of ICVU initialization, body, updation, condition, all these things. We ran the loops. Now, after this is done, we understood about while loop and do while loop, which also does the same thing, but it's just that we have different ways to write it. There is only one difference. So the for and while loop are entry control loop, or do while loop is the exit control loop. In for and while loop, the condition gets checked before entering the loop, and in case of do while, the condition gets checked at the exit of the loop. That's it. Dynamic programming is fifth. No, fifth में नहीं है. Dynamic programming is in the fourth module. It is not in fifth. I guess no, there is one. So there is one module in between. I guess it is third or fourth. There is a third or fourth module in between, which is not for programming. It is there for like databases, operating systems, networking, all the core fundamental computer science subjects. Okay. So there is one module in between. I guess in DSA that is the fourth. So you get one module in between buffer time to practice more DSA question before. पहले 4 में DSA, right? I guess the fourth one is this. One of them is not DSA actually. The fifth, if the fifth one is having DP, na, then the fourth one of the modules is having like 4 CSE subjects. Okay. Why this was structured in this way? Because students wanted more time to practice DSA. So there was one theory module that was stuck in between, so that you anyways need to learn them for your interviews. Those are also important. You need 1 month for them. So 1 month you learn them, and you get more time to practice TSA question for that month, right? Because that month you don't have anything much to do apart from seeing the theory, understanding it, learning it, right? Okay. Then we saw questions like print numbers, find some Fibonacci numbers, and so on, right? On this, and then we saw a lot of numbers on questions on numbers, basically print digits, sum of digits, even some count digits, print digits, and so on, right? Okay. Now let's move to the interesting part, which is over here. I also talked about this, which is unary, binary, and ternary operator. Unary operator is operators which work on one operand, like increment, decrement, and not, right? Binary operators are the operator which works on two operands, like plus, minus, into, divide, and so on. Sorry for that. Okay, so we understood about unary, binary, and ternary operators, right? So unary operator work on one operand, binary operator works on like two operands, and ternary operator works on three operands, right? Remember this. This is like a theoretical question, but it is asked in interviews, right? Unary, binary, or ternary operators ke examples, right? So you can remember this. You should remember this. You'll like this is the easiest thing to forget because you'll like you'll not use them in this way. You'll use all the operator, but you'll not remember the terms, right? Unary, binary, ternary. So just remember that. Okay. Now, after this, we did questions on loops, count the factors, prime numbers. We did pattern printing. Now, this was very important. So we learned about nested loops. And in case of nested loops, so there is two kinds of questions I told you, right? You have to run some logic again and again over a given range, right? So you are given a range and you have to run some logic on that range, like finding prime numbers in a range, finding factorials of all the numbers in a range, finding some digits all the range, right? And so on. Now, and then second thing was pattern printing. I gave you one simple trick to print patterns, right? So basically the outer loop will always run for the number of lines or the number of rows you have in pattern, and inner loops will always print each line of the pattern. Like if you just follow these two things, you will be able to print pattern of any particular kind, right? You are getting any particular diamond or star or pyramid or anything, right? You mean square, hexagon pattern, you will be able to print it. You just have to follow this, right? Even for the Pascal's triangle, we followed this logic. It even required additional memory, but the logic was same. Outer loop was running for number of lines, and inner loops we are printing how many like values we have to print in each line. Right. That's it. Okay. Anyone having doubts in pattern printing or anything on nested loops? Or is nested loop clear? Anything in nested loops that you have doubts? We saw different ways, right? So character patterns are again easy. Character pattern, I gave you the trick that you just have to treat it like a number pattern. So for example, this is a character pattern. So the equivalent number pattern for this is going to be like this, right? So A is going to be 1, B is going to be 2, C is going to be 3, and so on. If you are able to print this number pattern, just print the character pattern out of it, right? And for character pattern, you just have to take one thing into consideration. Once it goes beyond 26, you can do percentage 26. That will reduce that number to 0 to 26, which is fine, right? Next is we did like pattern printing for the Fibonacci series and so on, right? So we did so many different kinds of pattern printing, like reverse triangle, right angle triangle, and so on, right? Acha, diamond pattern mein how many of you have doubts? Anyone having doubts in diamond pattern? We did a lot of pattern questions actually. So I'll explain that. So I'll explain that. I guess usko kahin pe to logic. Okay. See, so what is diamond pattern? Diamond pattern, we basically have to like print the pattern in form of diamond. Now this is like very complicated to print, so I broke it. We can break it down into two patterns. So first pattern is this triangle, and the second pattern is this triangle. So in the first pattern, we are printing the triangles, right? Stars from 1, 3, 5, and so on. And the second pattern, we are decreasing it, right? 3, 1, and so on, right? So what we have to do is basically we'll first pattern is going to we are again the outer loop runs for order of times. Well, like the number of lines that we want to print in the first pattern, which is n by 2 plus 1, half of the lines plus 1, right? Whatever is n by 2 plus 1, this is the first half of the triangle. We run it for the number of lines. In each line, we first print the stars. So the star calculation is f minus I, and then we print the number of stars. That's it. Yahi karna hai. Stars ka calculation figure out karna hai, and there would always be a relation. For example, here the relation is 2i minus 1. Okay. So for ith line, the number of stars is 2i minus 1. Search box is control F. Control F is search. Control F is search in any platform, right? So if you do control F in any platform, that would enable search. Any application, the shortcut for search is control F. And global search is control shift F. So there is no global search over here, right? So anything that would have global search like Teams or VS Code or something, and that would be control shift F. Okay. And same thing we did for the other pattern. Yes. Yeah, I'll see the questions in chat just a second. The other pattern, we are just running it in the reverse order, where we outer loop again runs for S2I. which is the like number of lines we want to print the second pattern. And then we run this loop for printing the spaces, which is s minus I plus 1. And this loop, there is 2i minus 1 for the number of stars. That's it. Okay. So here the stars are decreasing. So we are running this loop in the decreasing order from s to 1. So the condition 2i minus 1 holds true for this as well. Yeah, holds true for this, and that's fine. Okay. Okay, so this is what is pattern printing. Then we, okay, now understood. Any doubts? Okay. Regarding placement, like if someone is 23 pass out and at which time companies hire 23 batches, like it's a. So 23 pass out is like you still have time for 3 to 4 months before you get your degree, right? So by the time you get your degree, you would be having. So there are companies who have like who are like who want immediate joinings. There are companies who can take you after 2 months or 3 months if you are like if you are still in like your college, right? So they are okay if you join them 3 to 4 months after it. That's also fine. Okay. Okay, next we learned about math functions. So basically there are mathematical operations that, so for example, we can do few mathematical operation like finding out largest between two numbers, smaller between two numbers, but few mathematical operation might be complex. For example, finding out square root or finding out the floor of a number or ceiling of a number or rounding of a number or finding out, let's say, the log of a number. So all such mathematical operations are complex. Then sine, cos, tan, or all such operations might be even more complex. So for that, we have mathematical functions using which we can find out, right? Few of these like functions are very easy, super easy, min, max, absolute, right? All these things we can write ourselves. We can write power function as well ourselves, right? So all these logics we can write ourselves. Square root is something which might be very difficult to write or implement. So we can use functions for mathematics, right? So we have the access to these functions. We can use them wherever we want. Wherever we feel necessity of using something like finding root, finding log, or we also have a function to find out a random number between 0 to 1. Right. I told you we can use this to generate a random number in any range. So this gives you the random number in the range of 0 to 1. Right. Now can you if you want the number to be in the range of 0 to 100, so you can just multiply it by 100. If you want it from 100 to 100, so you can multiply it by 100 and then you can add another 100 to it. So it will give you in the range of 100 to 200, right? So if you want from 1 to 300, you can multiply it by 300 and add a 1 to it. So that will give you in the range of 1 to 300 and so on. Right? Yeah. So this is what mathematical functions are. You can generate random numbers. You can use mathematical logic over here. Okay, clear? Shall we proceed to array? Or shall we give you a break? Just give me a second. Okay. Got it. Okay. Okay. So now let's move to the interesting part, which is arrays, right? So arrays are basically very important, right? You know, right, how important arrays are. all the other data structures are created out of arrays. Because arrays, like, you just don't have to think it superficially. There is a lot of things on arrays, right? So for example, we have memory, right? I told you a lot about memory. Our code runs in the RAM part of memory. We have cache, we have RAM, and then we have hard disk. We can have secondary storage like SSD or hard disk or something like that. Now from this RAM, we get a portion of RAM to run our code. And then we divide it into stack, heap, and something known as string constant pool, right? Because we have three sections of the memory: stack, heap, and the string constant pool. Now, any variables that you create normally goes into the stack. Any variable that you create using new keyword or which gets its memory in the runtime of the code is created in the heap section of the is created in the heap section. Stack is statically allocated. Heap is dynamically allocated, right? So these all things we learned, right? Okay, so arrays always gets created in the heap section, no matter whether you pass the size initially like this, or you create an array of size 6 or size 10, or you just pass it of n size. If you want to create any array of size n, you will get it will still get created in the heap section of the memory, right? Arrays are always created in heaps. It doesn't matter how you create that array. Arrays are immutable, right? So once the array is created, the length cannot be changed. You cannot add or remove numbers from the array. All those operations are not possible, right? So if you try to do any of such operations, like addition, accessing any array element which is not present, you get the error like index out of bounds, right? You can print. Now I explained in very detail what is the difference between address and a reference. What is so address basically. There are two types of address: logical and physical address. The address that you see over here is the logical address. Any address that you will be able to see is the logical address, right? Anyhow, if you get the address, that is the logical address. Physical address we don't have access to. That access is only that access is only with the operating system. It doesn't give us the physical address. It always gives us the logical address, right? With which we can update anything or like. It is like a MAC and the IP address, right? The address that you see over internet is the IP address. You don't know the MAC address of the device, right? But and here similarly you see the logical address. You don't know the physical address of that logic. There is a lot of reasons to show you the logical address, not the physical, because physical address can be a lot of things. For example, consider an integer variable. So it takes 4 bytes in memory, right? Say 4 byte होगा इसके memory में, and this 4 bytes can have like 4 byte is 32 bits. So there will be 32 physical address associated with this. 32 physical address होंगे इसके, right? 32 bits of memory, so 32 physical addresses होंगे. Now, which physical address will it show you? Right. So instead of showing one physical address, it will show you a logical address. And whenever you like something like this, some logical address like A, B, X, Y, Z or something like that. Something like this. Now, whenever you pass this logical address, it will automatically understand that you are trying to access a physical address of 32 bits, right? You are trying to access these 32 bits of physical address, which is this. Okay. So this is what physical and logical address is. This is how it differs. Now we have reference. So reference is basically a variable pointing to the logical address. Array variable is a good example of reference, which is like a variable that points to the reference that points to the logical address, which is the reference. If you print it, you will be able to see this like something like this. So this is the logical address, and here is the reference that is pointing to this logical address. Okay. We understood about physical and logical address, what it is, right? That we saw. And in case of 2D array, we understood how 2D array is actually present, right? So 2D array is not present like a matrix in memory. It is present as a multiple one-dimensional array, right? So first one-dimensional array stores the addresses of all the. So for example, a two-dimensional array. So it is a one-dimensional array where each array cell is a array, right? So each array cell here there is a like logical address that it stores AD123 something like that, and this is basically pointing to a array. This is pointing to the base address of another array, which is an array. This is actually the array that is storing the value. Same goes for here, right? So you basically have 10 such arrays present over here, and this array, which is like what's the logical address of this array? If you print A, you're going to get the logical address of this array. If you print A of 0, A of 1, you're going to see these logical address that are present over here. We did this, right? Remember found, so remember this. So a 2D array is nothing but a combination of one-dimensional arrays. Each cell in the two-dimensional array basically represents one-dimensional array, right? Remember? No, forgot. Yes, we can. Yes, it is like crazy. Yes. So architecture wise, it is crazy, right? It's interesting as well, right? So it's crazy, but it's interesting. Okay. Mm, okay. So now let's look over here, right? So okay. So once we're done with this, right? So we got physical address, logical address. We understood how a 2D array looks like, right? And then we like so how it is actually represented in memory, what is 2D array and so on. Now similarly, we can represent any n-dimensional array, right? That we also saw. I guess we also saw examples for that. Did we not? So I'll come to that, right? So basically, we can have any n-dimensional arrays as well. That is also fine, right? We can have any n-dimensional array, which is again two-dimensional array. So which is again a single dimensional array having addresses of another two-dimensional array. And in that like array, we again have addresses of another arrays and so on. That chain continues, and the last cell has the value, like something like that, right? Nested array. Right. So you can have one array which is storing the address of other arrays. So this is the first array which is storing the address of other arrays. Now this will store the address of another array. Each cell is this storing the address of another array. So this is a three-dimensional array. You store the reference of this reference, any a of 0 points to a reference of another array. Right? And here again a of 0 points to the reference of another array. And here a of 0 you get the actual value. Right. So basically a of 0 of 0 of 0 gives you the value. This is a reference, this is a reference, and this is the final value. Right. So this is the reference which is the reference of this. This is the reference which points shows the reference this, and this is the final value that you see over here. So similarly, you can create 3-dimensional, 4-dimensional, or any n-dimensional array. Right, the easiest way to visualize is something like this. Right, you can think it like this, which would be easier to think. So basically, this is a 2-dimensional array. So what is a 3-dimensional array? So in the 3-dimensional array, every cell of 2-dimensional array stores a matrix. You can think it in this way. This would is easier to visualize. In case of 4-dimensional array, every cell stores another 2-dimensional array like this. Right? How many of you seen Inception? You seen Inception later? So this is that movie Inception. Inception, there is a great example of how inside one dream you have another dream, and inside that dream. If you have seen Interstellar, there also in the end there was an example like where it flows from one time quantum to other time quantum. Right, there was also a similar depiction like this. If you have not watched both the movies Inception and Interstellar, right? uh, yes, and you will be able to understand these concepts. Okay, those are two very interesting movies. You should watch them, right? Yeah. Now over here we understood about decimal to binary. Now I'll talk about here like little bit about number systems, right? So we understood that we know the number system that we use is decimal, right? But there are other number systems, right? With decimal is not the only number system that exists. We have number systems like binary. Decimal is not the number system that exists, right? We have binary, we have octal, we have hexadecimal, or basically you can create a number system, or and you can whichever number of character, whichever is the amount of number of digits you or numbers you want in the number system, you can use them, right? It doesn't matter, right? You can create any number system. These are the some things which are commonly used. Hexadecimal is one which you use for color code, right? So we saw it in color codes, right? Hexadecimal numbers represent color code. So any hexadecimal number combination like 1, 2, A, B, C, 3. So this is a hexadecimal number combination, right? This is a hexadecimal number representing a color. This is used in pixels and all those things. So all the colors that you see on the screen is nothing but hexadecimal numbers. Okay. Now we have binary numbers that we know, right? So any calculation, anything that goes in the code is binary numbers. So everything that computer does is in the binary form. It doesn't understand decimal, octal, or any other numbers. Ultimately, everything is converted into binary. We run the binary logic, and then whatever number system we are using, it gets converted back to that. So the one that we know is decimal, which has 0 to 9 digits. Binary is only 2 digits, 0 to 1. Octal has digits 0 to 7, and hexadecimal has digits 0 to F. Achha, how many of you remember the conversion? How many of you forgot? Tell me honestly. Conversions yaad hai or you forgot? Remember? Chalo, forgot. So I'll show you one so that you can easily you can easily get reminded of it. So let's say we have a number like 32. We want to not 32. Let's say 34. Not 34. Let's say 38. So let's take some number like 44 लेते हैं चलो ठीक है. Let's take 44. We want to convert 44 into decimal number. ठीक है. So divide binary number. So divided by 2, we get 22. The remainder is 0. We divided by 2 again, we get 11. Remainder is 0. We divided by 2, we get 5. Remainder is 1. We divided by 2, we get 1. We divided by 2, we get 1, and the remainder is 0. Okay. So now this number is your binary representation, which is 101100. This is your decimal to binary conversion divided by 2, and the remainders you write from bottom to top. That is your decimal to binary conversion. Okay. Now next, once you got this binary number, what you can do is you can convert it back into the decimal if you want, right? So for example, if you want to convert this back into decimal, what you need to do is you can just take 0, 1, 2, 3, 4, 5, and so on. 1 into 2 to the power 5 plus 4 into 2 to the power, 0 into 2 to the power 4 plus 1 plus 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 0 into 2 to the power 0. So this is 32, 2 to the power 5. This is 0. This is 8. This is 2. 2 to the power 2 is 4. And then we have 0, 0. So 32 plus 4, 36 plus 8, 44. Let's we get this number. So basically, this is how you convert by dividing from any number by 2, you convert it into binary. And now by multiplying, right, you start with the end. This is 0, 1, 2, 3, 4, 5. And you just multiply 1 into 2 to the power 5, 2 to the power 4, 2 to the power 3, square, 1, 0, and so on. Right? And you finally get the number. Understood? Yes, no? आज ब्रेक का प्रोग्राम नहीं है. Yeah, I also forgot. Let's complete a little bit more and then I'll give you a break. ठीक है? हम if you want break, I know. अच्छा आज हमने जल्दी start करा था, right? Okay, chalo, I think we can pause over it. Now similarly, like for any other number, right? If you have any other number, decimal to any other number conversion will be if you want to divide want to convert octal divided by 8, if you want to convert to hexadecimal divided by 16, and so on, right? And if you want to like convert any other format, so for example, any other number to decimal, you just multiply it by 8 to the power 5, 8 to the power 4, 16 to the power 2, 16 to the power 3, and so on, right? So you just need to do that division, multiplication with that respective powers, right? 2, 8, 16, and so on, right? So you just have to divide and multiply by that powers of that which is the base of that particular. Now there is ways using which you can directly convert binary to octal or binary to hexadecimal, but I would say don't remember them. There is no need. You can convert binary to decimal, and then you can easily convert that decimal number to octal, right? So decimal to hexadecimal, any other number system you want. So you can just remember these two things that will do the work for if you want to convert from decimal to like binary to octal or binary to hexadecimal. All those things can be also covered by this ways. Okay. So this is it about conversion. Anyone having doubts on conversion and still, is it clear? Did you did it remind you about conversion? Yes. Yeah. Okay, chalo, I guess we can take the break, right? Go have your dinner. I am also feeling hungry. Okay, so let's go quickly grab your dinner, eat something, come back. We'll complete this and then we can discuss your questions. We are almost halfway. Halfway. Okay, I thought we would have reached चलो ठीक है anyways. Okay, ठीक है चलो. Now ठीक है, I guess we'll complete this. चलो let's take a break, right? I guess break ले लेते हैं. Okay, quickly come back, have your dinner, and then we'll see. Hello everyone. Welcome back. I hope you all had your dinner. Okay. आज 2 बजे तक पढ़ा ठीक है चलो we'll continue till 2 we'll continue till 4 right and then tomorrow I'll not go to office. Okay, so let's try to complete it as soon as we can, right? So we're almost halfway through. Let's go through the remaining part. Okay, so now we saw this, right? We understood about what is conversion from one data type to like one number system to another is going to look like. Okay, then we did array questions, right? We saw a question like second largest number of array where you can like these are the questions, kind of questions where you should ask question to the interviewer, right? You should not proceed to write solutions without clarifying this with the interviewer. Okay. Next, we saw like how can you find out the largest number, how can you find out the second largest number, and so on. 100 students. Yes, sure. We'll teach you too if we are left with doubts. Okay. If you are not, if you are done, then we'll stop. Okay. Next we learned about arrays, subtraction, arrays like addition, subtraction, subarrays, right? All these questions. So we saw one algorithm, a very famous algorithm, Cadence algorithm, which is to find out the largest subarray sum. So okay, before that we discussed about time and space complexity, right? So what is time and space complexity? It is basically a measurement of how much time does a code take to run, right? Do you work from home or office? Now, like I work from home partially from office. It depends on my mood whether I want to go or whether I don't, right? So that's how it is, right? No compulsion to go to office. If you want, you can go. If you don't need to go. Huh. Slow from time and space and complexity. Yes, I'll do this. Nowadays, all the IT jobs are like this, right? If you want, you go to office. You don't want, you don't go to office. Because anyways, you're doing the work, right? Okay, so I'll talk about those things, right? Let's complete this one. Now, time and space, I want 5 minutes of your dedicated time, right? So listen to this very carefully. So what is time? So this is like a measurement of how much time our code would take. So do we actually measure it in seconds, minutes or something? No, actually don't measure it in seconds, minute or something, right? Because it might be different, right? The code might take different time on my system, on your system, because we have different processing power. We have different capabilities of our system, right? So we our code might take different times running on different systems. So how do we actually measure time? So since the time, the actual time that is taken by the code is different, we measure it in terms of big O, omega, or theta, right? So for right now we just learned about big O. Later we'll learn about theta and omega as well. Okay. What is big O notation? Big O is a simple notation to denote time. So big O of 1 means constant amount of time or any fixed amount of time is denoted as big O of 1. So for example, any single statement is big O of 1, right? Any multiple statements is big O of 1. A loop that runs for fixed number of iterations is also big O of 1. Why this is big O of 1? Because it takes fixed amount of time. Right? If I run it multiple times on my system, this code is going to take fixed amount of time. It's not going to vary. Right? So any constant or fixed amount of time is known as big O of 1. Okay. Now, apart from this, like, so everything is constant or fixed, and what are the variable factors? So what are the other time components? So we have order and complexity like this. If we run a loop for order n, so that is order and complexity, right? If you run a loop for like two nested loop order n, so this becomes n square, right? Because any statement that you write over here will run for n square number of times. So basically, this is a measure of how many statements you would have in the variable in the order of n, which is the variable thing. Right, so this gives you idea whether a logic is going to run or not. So for example, if it is n square and your n value is at max 10 to the power 3, so it is going to work, right? We have a constant that you can run at max 10 to the power 8 lines of code in 1 second. You cannot run more than that. Given that constant 10 to the power 8 lines of code in 1 second, you have to validate whether your time complexity is going to work or not. So for example, here it is n cube, right? If you have 3 nested loop, now you can increase it 4, 5, so on, and it will end with power 4, 5, and so on. If you have 3 loops running for order n, m, and k, so this is here the complexity becomes sum out of that, right? N plus m plus k, because these are total number of lines of code. Okay. If all of them are equal, so it is 3n. So any constant into n, we represent it as order n. Any constant multiplied with n, 3n, 5n, 7n, 10n, 100n, we represent it as n. But now, does it mean that it is actually equals to n? No, right? So in big O terms and in actual time, in actual number of lines of code, it might differ. For example, 10n will represent it as order n. But if n value is 10 to the power 7, Is it going to work? Yes. But it n value is 10 to the power 8. Is it going to work? No. Because for 10 to the power 8, this is going to become 10 to the power 9. It is not going to work. But for 10 to the power 7, it becomes 10 to the power 8. So it works, right? So this logic will work for n value 10 to the power 7, but not for 10 to the power 8. Even though we are writing time complexity is 10 to the power, big O of n. Okay. So the representation might differ from the actual number of lines of code because it just considers the variable parameter and we ignore the constant parameter. But the constant parameter can put impact on calculating the actual number of lines of code, which is going to impact your time. Okay. 5 into 10 to the power 4 is going to show TLE, right? So see, 5 into 10 to the power 4, now see 5 into 10 to the power 4. Okay. And you have like just n square, right? Your complexity you're telling is n square. So you get this. So it is 25 into 10 to the power 8. So it is 2.5 into 10 to the power 9. So this is order of 10 to the power 9, not 10 to the power 8. So this should be TLE. Right? So your big O denotes like what's the variable parameter. Now you can put the actual values and try to calculate the value. Whatever you'll get, that is the actual number of lines of code. 5 into no, it's not 5 into 10 to the power, it's going to be 25 into 10 to the power 8, right? It's not going to work. 5 would work, 6 and 7 would work. Around 8 into 10 to the power 8, you might see things is breaking. Now this is square root of n, where you are running for root n times, right? There are two ways to write it. Either you run this loop for root n times, or you run a loop that is I into I, and you check for less than n. So this is also root n, right? So in both cases, it is root n. Either you run the loop for root n times, or you run it in this way. This is also root n. Then you have like any loop running for n by 2 is also order n. This is constant into n, that is order n, right? Then we have log n, where we are multiplying it by 2. So this is log n, right? So where you're multiplying this by 2. So you're running for like I told you, right? The easiest way to observe this is if you would get patterns like this 2, 4, 8, 16, 32, 64, something like the multiples of 2, like powers of 2 or powers of 3, 9, 27, no, 27. This into 3 is 27, this into 3 is 81, this into 243, and so on, right? So you get multiplication, multiples of everything is just multiplied by 3. This is a geometric progression, this is a geometric progression multiplied with 2, and so on. If you get things like this, you can simply say that is a log n complexity. Okay, understood? When you can say it is log n, बस वो pattern observe करना है. So log of log n था ना, that we saw today, don't confuse with that because that was completely different, right? That is a complete different. This is the easiest way to get the log n complexity. You'll see a pattern like this. If you these are the values of I for which your loop is running. Your loop is a log n complexity. Okay. Oh, sorry. If in GP, then it is log n. Yes. If it is a geometric progression, then it is log n. Square root mein you will see something like this, right? So you square root mein there is no such series. You would see the final value. For example, for if n value is 25, your loop would run for 5 times, right? So for example, in this case, 5 into 5 is less than 25, your loop runs. But if you get I is 6, 6 into 6 is not satisfying, right? So for 36, it would run for 6 times. For 49, it would run for 7 times, something like that, right? So if you see pattern like this, that is root n. N log n is better than square root n? No, square root n is better than n log n. Square root n is better than n log n. Na? ये तो order n से less है ना? This is less than order n. This is less than order n, and then it is n log n. N log n is even n log n is worse than order n, right? It is a multiple of n. So this is worse. So square root of n, then n, and then order n log n. Okay. Now you can create combinations of any of such these. Like the last one was exponential, where we are running for any 2 to the power something, you run it. So this is exponential complexity. The worst is factorial, then you have exponential. So these two are something which you will never use, right? Most likely, this is something which you will use in case of a recursion or something, but you will optimize it later. So this is something which you will get in case of recursion or like this, but you will optimize it. Then you have exponentials power 4, power 3, and so on, order n. Finally, root n, and then log n. So this is the order in which it is better. Log n is better than square root of n. Yes, log n is better than square root of n. If you print the prime numbers, then also it is going to be no n log of log n is c n log of log n. I have to check. I guess if you take or if you print it, that is on. This is order this. Now I guess this one is worse than this. Acha, log of log n is less than 1. Okay. Yes, so then so if you print it, then it is going to be order n. If you print it, it is going to be order n. If you don't print, it is going to be that, right? So most if you print it, then it is order n still, which is better than n root n, right? So for example, if you check for any range, you will get n root n, right? Which is not good, right? So for n numbers in a range, you are getting in order n, that is fine, right? That is great, you including the printing part. Okay. So this is what time is, right? So this is now we can create combinations like n root n, n log n, right? N square root n, n square log n, n cube, n square log square root n, or n square log n, or something like that, right? You can create combinations of these, which will be also like which will also follow the complexity, right? So if you have multiple loops, so this is order n, this is n root n. So the final complexity is sum of them. So order n plus root n is order n. So if there are multiple complexities, take the like highest one, because this is the bottleneck. If you don't optimize this, no matter how much you optimize it, the complexity is going to remain order n, right? Then we have space complexity. Space is also considered similar to time. You find out the complexity in terms of big O. So any constant space is big O of 1, like a string like this, variable like this, or array like this. So this is also a constant space. So these are known as big O of 1. Now, array of sizing having order n or n square size array, all these are like order n or order n square space. That's it. Okay. So this is what time and space is clear. Time and space, still doubts? Yes, no? Clear. Chalo, great. Why am I feeling sleepy? What happened? Is any one of you feeling sleepy? Acha, how many of you are planning to watch the match tomorrow? How many of you are too much? How many of you are planning to watch the match tomorrow? Anyone? See, I'll tell you one thing. If you see someone yawning, now you immediately get a yawn. If you if you see someone yawning, you immediately get a yawn. And today the weather has also been very good. Like first time there is like so much rain in Noida and Delhi. Okay, so let's complete this. Right, let's quickly go through it. We have a small part of it remaining. It's raining. It's raining in Rajasthan. Okay. Okay. So I guess then you might be living inside of in a place like Jaipur, not in the desert area, like Jodhpur, Bikaner is like not that towards the west. Also in Kerala, I guess today there is been rain in a lot of places in India. Good day, right? Okay. So revise space complexity again. See, space is nothing but we just measure the space again in terms of time. See, space, in case of space now, you won't get cases like log n, square root of n. Rarely you would see something like that. Most of the time your spaces are either constant, or you have orders n space, like if you create an array of size n, or if you create n square array, then it is size of n square, right? So that is a n square array. That's it. So this is your space complexity, right? Order n square, or a constant amount of space. Understood? Now that's it. If you create a string of n size, that is again order n space. If you create a log n and log of log n, so log of log n is just this, right? So log of log n कोई complexity नहीं है. It was just specific for a sieve of Eratosthenes. So this thing is log of log n, a series like this. So this sum of series is log of log n. This is a special case in case of sieve of Eratosthenes. You won't get this in other questions, right? Asymptotic time complexity का मतलब क्या होता है? What does it mean? So asymptotic time complexity, अच्छा, what does assumption mean? So we are assuming something, right? So this is a assumption, or you can say it is like a near time complexity, right? It is not it is like a mathematical derivative. It is not the actual time. It does not represent the actual time. It does not. So time should be always represented in seconds or minutes or hours. Do we represent the time in seconds, minutes, or hours? No. We just assume it. We just try to find out the how we just try to find out the comparison between them to say just by code if it is n square or n cube, which one is going to perform better for a given value of n, right? For if the n is fixed, so this in this two logic, if I compare them, n square is going to work better as compared to n cube, right? So that is known as asymptotic complexity, where we are comparing the complexities by using mathematical functions, not by actual time. Because we are not comparing the actual time, we are comparing the mathematical functions or mathematical derivatives which represent time. Okay, understood? Okay. So next we understood about garbage collector. Now this is like very important, super important. This frees out all the variables that has gone out of scope. This creates your memory. This makes your memory again available to be reused by arrays or other variables, so that you every time have access to memory and keep in reusing it, right? Now, like after this, we learned about subarrays, subsequence, subsets. So basically, we saw a lot of questions on subarrays. You'll see questions on subsequence and subsets going forward. So subsequence questions, you'll see a lot of them when you learn about dynamic programming. And so subset questions also, you'll see a lot of subset questions. You'll learn about hash map, hash sets, and so on. Okay. Right now we saw subarrays questions, which is basically a continuous part of array. Now there can be questions like find out the largest subarray sum, or subarray sum of size k, or which is the largest subarray sum of size k, right? And so on. So I can recap the, how many of you don't know about log? I can explain it. How many of you want to revision of log? See, log is very super easy. It's not difficult. See, this is what log is. So we know how to represent powers in 2 to the power something like. So let's say we have done 2 to the power 5. 2 to the power 5 is 32. We can write the same thing in terms of log by writing log 32 base 2 is equal to 5. This is what logarithm is. Simple. This is what logarithm is. Logarithm is nothing but a different way of writing power. 2 to log 32 base 2 is 5. Acha. Tell me, if I tell the complexity is exponential 2 to the power, what does this mean? That you have 2 to the power n lines of code, right? If your n value is 10, then you are going to have 2 to the power 10 lines of code. Yes, this is what it means. You get this understanding, that if I say the time complexity is big of 2 to the power n and n value is 10, so you understand that immediately in code we have written 2 to the power 10 lines of code. Okay, if I run this logic, this is going to translate to at max 2 to the power 10 lines of code, which is 1024. Now you find out, okay, 1024 is way less than 10 to the power 8, it is going to work. Same way in case of log, when I say the time complexity is log n and I say the value of n is 100, I simply mean that we have log 100 lines of code. Now what does log 100 lines of code means? Log 100 lines of code का मतलब क्या होता है? Let's say n value is 100, so log 100 lines of code कितने होंगे? So it is roughly around 5 to 6 lines of code. Okay, so we have 5 to 6 lines of code, which is way less than 10 to the power 8. So this is going to work, right? So let's say n value is 10,000 or 1 lakh. So what does we mean? So we have 1 lakh base 2, these many lines of code, whatever value this comes out to be. Let's say 50, 100, 500, whatever values. So let's say it comes out to be 20, 25 value. Okay, so we basically have 20, 25 lines of code, and it is going to run for if you run for n equals to 10,000 or 1 lakh, something like that. Okay, चाहिए log. This is what log is. Log is nothing but a different way to represent power. Whenever I say log n, we simply mean in our code we have log n lines of code. If you put n and you put base 2, these many lines of code we have. Okay, that's it. N log n is basically writing two loops. Outside loop is running for 1 to n, and the inner loop is running for log n times, right? This is running for, let's say, 1 to log n times. Okay, so you have log n lines of code that is running for n times. So how do we represent something like that? So n log n. If inner loop would be running for square root of n, you write n square root n. Or if inner loop is running for order n, so you write n square, right? So that's what, in case of log also we are writing it in that way. Clear?
सर मतलब ऐसा हुआ क्या, जैसे log 200 है, मतलब 2 की पावर को क्या करे कि 100 आ जाए? वो
हाँ, 2
उसकी
की पावर
वैल्यू
को कितने से रेज करेंगे तो 100 आएगा, 5 और 6 समथिंग आएगा, राइट? 5 6 समथिंग है। तो बेसिकली हमारे पास 5 6 लाइंस ऑफ कोड होंगे। ठीक है, अब यहाँ पे जो हमने लॉग वाला कॉम्प्लेक्सिटी बताया था ना, यहाँ पे बताया था मैंने लॉग कॉम्प्लेक्सिटी। देखो यहाँ पे n की वैल्यू 100 रखो, चेक करो लूप कौन कौन से वैल्यू के लिए रन कर रहा है। 1 के लिए रन कर रहा है, उसके बाद वैल्यू 2 हो जा रही है, 2 के लिए रन कर रहा है, फिर वैल्यू 4 हो जा रही है, 4 के लिए रन कर रहा है, ठीक है, 1 हो जा रही है, फिर 2 हो जा रही है, फिर 4 हो जा रही है, फिर 4 से मल्टीप्लाई होगी,
8 हो जाएगा,
फिर 16 हो जाएगा, फिर 32 हो जाएगा, फिर 64 हो जाएगा। इसके बाद लूप ब्रेक हो जाएगा। कितने बार लूप रन करा? 7 टाइम।
7 टाइम।
तो लॉग बेस 200 ये कितना है? 6 आ रहा है, समथिंग 6 पॉइंट समथिंग आ रहा है, तो हमने बोला 7 टाइम्स अराउंड रन करेगा लूप।
ये प्रोग्रामिंग में हमेशा log 2 ही लेंगे क्या सर?
नहीं, कुछ और भी होगा। अगर मैं यहाँ पे मल्टीप्लीकेशन फैक्टर को 3 चेंज कर दूं या 4 में चेंज कर दूं, तो ये उसके टर्म्स में रन करेगा 3 4, राइट? तो जनरली इतना स्मॉल आता है ना, 3 4 समथिंग, तो हम इसको इतना स्मॉल कंसिडर करते हैं। देखो एन की वैल्यू 100 थी, हमने 5 6 बार लूप को रन करा है। 3 होगी तो और कम रन होगा, 3 मतलब 5 बार 4 बार रन होगा, ठीक, और कम जाएगा। तो हम हमेशा इसको जनरली 2 बोल देते हैं, बट ये जनरली लॉग एन लिखते हैं, हम बेस बताते नहीं है। बट मोस्ट ऑफ द टाइम इट्स 2, बट ये डिपेंड करता है ये वैल्यू क्या है। 3 होगी, 4 होगी, 5 होगी, so it will vary for this, right? So 3 होगा, it will run for 1 3 9 27 81 and so on। ठीक है, so इसमें 5 टाइम्स रन होगा।
ओके सर, समझ आ रहा है।
हाँ, no, when like we generally say it is base 2, देखो base 2 is the worst, right? base 2 से पूरा क्या होगा, right? base 2 से पूरा क्या होगा? base 3 base 4 होगा, so it is going to even run for lesser number of times। base 2 तो सबसे worst है। base 2 में सबसे ज्यादा टाइम्स चलेगा। base 2 से कुछ भी बड़ा बेस होगा 3 4 5 6, so और वर्स और कम टाइम्स चलेगा, राइट? तो हमारे तो और बेटर है ना, हमारे लिए जितने कम लाइंस ऑफ कोड है उतने ज्यादा तेजी से चलेगा कोड, ठीक है? तो वो हमारे लिए और बेटर है। तो हम बेस 2 बोल देते हैं कि सबसे वर्स्ट सिनेरियो में अगर बेस 2 भी है तो भी लॉग एन चल जाएगा। और लॉग एन ना एक्चुअली में बहुत छोटा नंबर होता है। इफ यू जनरली लॉग, सो यू ट्राई टू फाइंड आउट द लॉग n ऑफ 10 टू द पावर 18, इसका लॉग फाइंड करो, ये कितना होगा पता है? दिस विल कम आउट लेस देन 50 होगा। दिस इज लेस देन 50। अगर n की वैल्यू 10 टू द पावर 18 है और लॉग एन लॉजिक लिखा हुआ है तो 50 इटरेशंस भी नहीं चलते लूप, 50 लाइंस ऑफ कोड भी नहीं है, ठीक है? सो लॉग एन इतना छोटा होता है वो बेस 2 में। और बेस 3 बेस 4 बेस 5 होगा तो ये तो और छोटा हो जाएगा, इससे भी छोटा हो जाएगा, 20 30 इटरेशन चलेंगे। सो लॉग एन इन जनरल बहुत छोटा कॉम्प्लेक्सिटी है, लाइक वो कुछ कांस्टेंट नंबर आता है 30 40। ओके, सो लॉग एन इज अ वेरी स्मॉल नंबर when you even if you have n as a very large number, right? So even if you have n like in order of 10 to the power 18 or something, right, you take 2, still it comes out to be 50 or 60 something like that. This value would come out be in 40 50 range, right? This is itself so small that if you take 3 or 4 or 5, this is even going to decrease to something like 20 to 30 or something like that, right? So so we are considering worst scenario. Let's take 2. Let's forget about base. In the worst scenario, even if it is 2, our iterations is so small that for larger number it is definitely going to run. If it is running for 2, then it's for 3 4 5 so on, it is going to run for every value. 5 multiplied for 10 to the power 18 times? No. It is 5. So it is like this: 5 1 25. So these are the I values for which it is going to run until it is less than 10 to the power 18. And it is very soon going to become 10 to the power 18, 125, 625 multiplied by 5, it is going to become 4-digit number, something like that. इससे भी बड़ा होगा, right? It is like 2 4 something, 2 4 5. Let's consider 2500. Simplicity, 2500. It would be in the range of 2500, then 10,000, then 50,000, then 2,50,000. Then if you do it, it would even come 12,50,000, 50 lakh, right? So on it increases super fast, right? See, from 1 to 50 lakh, we reached just in around 10 iterations, not even in 10. And it would go to 10 to the power 18 very soon. In 20 to 30 iterations, it would reach 10 to the power 18. Right, so that's how fast a log complexity, that's how fast it grows in case of log n, right? Because you're multiplying, right? It is a multiple, it is a geometric progression, right? Chalo, मैं show करता हूँ. Actually, let me show you something. I guess I showed you, but you forgot this. Powers of 2. See, so 2 to the power 63 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So around 2 to the power 20 is equals to 63, right? If you have a number in the range of 2 to the power 20, it will run for 63 times. See, so small iterations you will get, right? So if your log base is 3, 4, or 5, something like that, your value is even going to be less, right? The number of iterations is going to be very less. So that's why log n is very small complexity, right? The number of iterations is so small that you can even consider it as similar to O1 complexity, because the iterations are so small that you can tell that it is like a very constant complexity. 20, 30 iterations is not big iterations, right? Okay, got it? So that's why in case of log, we just simply say log n. Even if you take 2, the iterations are very small. If you take 3, 4, 5, any larger number, the iterations are going to become even more smaller. So it doesn't matter. Iterations are negligible. But yeah, the log definitely is associated with the base, given the like how you have written the code, how your I value is increasing. Okay, now clear? Now you don't have need to watch the YouTube recording or for login. You still need, you can understand little bit about log, but this is what log is, right? Okay. Next, we learned about arrays like subarrays, subsequence, and so on. So subarrays are basically small part of arrays. Subsequence are part of array, but they don't need to be consecutive. For example, 2, 4, 2, 4 is a subsequence, but it is not a subarray. 2, 4, 6, 2, 4 is a subarray, right? Then subset is basically any numbers not in any order from the array. They just have to belong to the array. That is a subset. Okay, any set of numbers picked from the array, a part of array which may or may not be continuous, but in the order of array is subsequence. A continuous part of array is subarray. Right now we did questions on subarrays. Later you're going to do questions on subsequence and subsets as well. Okay, so we printed all the subarrays. We find out the sum of all the subarrays, right? We found out the maximum subarray sum. We did it using an n cube logic, right? We find out the sum of all subarrays and we check which one is maximum of them. Then we move the sum outside. Classic example of how we can optimize. So we saw some operation that is getting done again and again. So what we did was we moved sum outside, and every new number that we are adding to the subarray, we just added that to our sum. So this gave us our subarray sum, and this is n square logic. Then we had an algorithm known as cadence algorithm, using which we can optimize this. And we used a simple technique that if the sum becomes negative, we can start fresh from a new sum, because that is going to give us a new sum, right? And this we got like the largest subarray sum. Okay, understood? Any doubts in cadence algorithm or subarrays? Is that clear? Cadence algorithm? Yes. Okay. Dekho, n cube and n square logic is clear for this question. Finding out subarray sum. Okay, so let me explain the cadence one then. So see, what we are doing in cadence is a very simple logic. What I'm telling is, we'll start from starting, we'll take on the sum until we get on positive sums, right? We'll keep on taking the sum. See, so we get sum as positive, we check if it is greater than max, we store it as max, we store the start and end index, okay? And we check if the sum has become negative. No. So the sum keeps on becoming greater than max, we keep on storing the new sum. Now let's say here we got the sum, okay? We get 43, which is the largest sum till now. Then we got minus 60. So we'll get, our sum will become minus 17. Now here, see, sum is not greater than max. Our max is 43, which is fine. but sum has become negative. Now, if you carry this sum forward, you're like you might get a larger sum without carrying minus 17. But if you carry 17 minus 17, your sum might become smaller. So what we'll say is, if the sum becomes negative, then we'll start fresh with a zero sum. Okay, we'll mark the sum as 0 and we'll start fresh. We'll update the starting index as well, right? So until the sum is greater than 0, we'll keep on carrying that forward. As socho, if we are trying to take something, right? We are trying to take something from the left. If it is positive, we'll keep on taking this. If it is positive, 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 we'll keep on taking it until it becomes negative. Once it becomes negative, if we take this forward, it is going to reduce the sum instead of increasing it. Right? Agar hum minus 17 ko forward lete, it is going to reduce the sum instead of increasing it. Right? So what we'll say is we'll start with 0, fresh again. So we'll take 2, 2 plus 4 is 6. 6 plus 8 is 14, 14 plus 3 is 17, 17 plus 15 is 67. Now this is greater, right? So we'll update this max is 67. So now we got the greatest sum. Instead, if it would have taken minus 17 forward, we would have got 50, which was not the greatest subarray sum that we could make from this array, right? So this subarray sum is greater. So we'll keep on taking the sum until it's positive. If it becomes negative, we'll start fresh with a new sum. But in cadence, we are not getting sum of all subarrays, right? We are not finding out sum of all subarrays. We are not doing that. We're just finding out the largest subarray sum. So cadence algorithm is just to find out the largest subarray sum, right? It is not to find out the sum of all subarrays or something. Okay. Understood? Clear? Yes, no. Okay. Next, we found out the maximum subarrays, maximum sum subarray of size k, right? So this was one assignment. So this was easy, right? You don't need any guidance or something. You can just do a sliding window. You can just take a subarray of size k, let's say 4, and then you just need to move the subarray. How will you do this? How will you find out the subarray sum of this next subarray sum? How will you find out the next subarray sum? If this is the first subarray sum, how will you find out the next subarray sum? Reduce the first number and add the new number. That's it. This is the next subarray sum of size k. If you reduce the first number and add the next number, this is the next subarray sum of size k. Reduce the first number, add the next number. This is the next subarray sum of 9. Reduce first and add the next. That's it. This approach is known as sliding window because your window size is fixed. So our size of window is fixed, which is 4, and we are sliding it. Right? We are sliding it, reducing something from start and adding something at the end. So this approach is known as sliding window approach. Kind of scroll, yes, kind of like a horizontal scroll. Like for example, this scroll that we are having on page, right? So this scroll that we are having on page is a horizontal scroll, right? So similar to that we are doing over here, right? We are sliding this, reducing something, adding something. Okay, I guess this is it. Now, we understood about memory, we understood about nested loops, we understood about arrays, we understood about nested arrays, two-dimensional arrays. We solved questions on 2D arrays, right? 2D arrays questions are, I'll say, comparatively simple. Like there is not any concept apart from like diagonals or something. Everything else is just one-dimensional array concept. You just have to use it in 2D, right? So basically, doing rotation, clockwise, anti-clockwise printing is just printing the array in a different way, right? That's it. It's just printing the array in different way. I even told you, right? How can you figure out? Now you can print any one row. You can print the diagonals. You can print the diagonal order traversal. The interesting questions were here was array addition. This was very interesting question, right? So array addition was interesting, where you have to take a resultant array. Your size might be different, right? Till now we have not studied about array list. Now you can know, right? How can you create an array list so that you don't need to do an operation like this at the end, where you want to remove a leading zeros from this, right? And so on. Then we did array subtraction as well, where we are subtracting it. We did diamond pattern. That's great, Himalaya. Right. How many of you solved array addition and subtraction by yourself, or partially? We almost reached almost to the solution. So these are kind of questions which takes time, but once you figure out the logic, right, You will learn a lot of things, right? Lot of things about how to manage edge cases, how to handle like different scenarios, right? And that's fine, right? No two logics can be same, right? If you write a code, I write a code, so the logic is definitely going to be different, right? So for example, here we write code, so all the developers logics are different to do the same work. Frequency of all digits and print them in the sorted order, right? Okay. Now we did permutations in one tab, right? What's the permutations that we can create? Array subtraction, right? Finally, this question was asked so many times and we did it over here. Array subtraction, how can we subtract two arrays? There were a lot of edge cases to consider if A is equal, if the array lengths are equal, if the array lengths are not equal, which one is greater, which one is smaller, we have to figure out, and then only we can perform the subtraction by taking borrow and so on, right? So there is a way to do array subtraction using recursion, which is a very small code, right? 10, 15 lines of code, but which works fine. Right now we don't know recursion, so I can't explain that logic. In the next module, you'll learn about recursion. So there you can see, you can ask this question again. How can we do array subtraction using recursion? Okay. A recursion hard? I would say it's easy. Only see, recursion is hard. I think I'll tell you one advice I'll give you for the next module. So recursion is very hard if you try to understand it. It's very easy if you don't try to understand it. Okay. Now, now your question would be, how will we write a code if we don't understand it, right? How will we write the solution if we don't understand recursion? Actually, you don't need to understand. You don't need to run it. If you try to run a recursive code, right, you'll never get the solution. You'll stuck in a loop and you will be not able to think, right? You just need to figure out two things in recursion, right? Base case and a repeated condition, smaller problem. That's it, right? Never try to run a recursive code while thinking of solution, right? Because you won't be reaching to the solution. Okay. Okay, now last 10 days, right? What did we do in last 10 days? So we understood about array list. What is array list? It is like a flexible and mutable array. Is there anything a flexible and mutable array? Something like this can exist in memory? No, it is fundamentally not possible, right? So what is array list? So array list basically is array, and it follows a simple strategy of what it does is basically whenever you create an array list, it creates it of a default size, right? If you don't specify the size, the default is 10. Now, if you exceed more than 10, what it will do is it will create an array list array of 20 size, copy all the numbers from the first array to this array, and then it again has 10 spaces empty. If you enter the 21st element, it will again create an array of 40 size, copy all the array numbers from the second array to this array, and it will allow you to insert new array elements in the end, right? So insertion and deletion in middle, yeah. Okay. Array, now here insertion at the end is O1, right? Remember why it is O1? Because let's say if you want to insert 1000 elements, okay? You created a 10 size array, then you'll create it 20, then you'll create 40, then you'll create 80, you'll create 160, 320, 640, and 1380, 1280, right? Something like this. So you'll require only around 1, 2, 3, 4, 5, 6, 7, 8. Only 8 operations would be order n. This would be order n, and rest 992 operations are O1 operations. So you can say 99% of operations are O1 operations, and only few operations are less than 1% operations are ON operations. If you actually try to figure out the time complexity is O1, because more than 99% of operations are O1 operations. So that's why we tell the insertion at end is O1. Now, what is the insertion in middle or deletion from start or insertion at start, or what is the complexity of this? So you can do insertion at middle or insertion at start. All those things would require shifting. So for example, if I want to insert any number at this index, all the elements needs to be shifted by 1. Now shifting is a order n operation. So insertion at middle is On, insertion at start is On, or insertion at any particular index is On. Same goes for deletion. When you want to delete something from middle, what you would want to do is you want to shift everything towards left. Okay. So everything would get shifted towards left. This is again our order and operation. So insertion at middle or deletion at from middle or deletion at start or insertion at start, all of them are order and operation simply because of shifting. Right? There is no other way to achieve it. We cannot create memory, we cannot delete memory. So the only way to do this is in actual memory is by shifting of values towards left or towards right, which is our order and operation. Okay. And this is what array list is, right? In this, now you have functions to do these operations like addition, remove, like insertion, all those things. We created Pascal's triangle, right? So which is basically using array list. We created Pascal's triangle too. We did a question which is find a way, which is again two-dimensional matrix where we found a way out of a matrix. We used like row, column, and this is one question where you should think simple, not too much complex, right? So you would get a cleaner code, right? We did maxima minima, right? I told you multiple ways to do this. So one way was to like run a n cube logic where you are finding out like for each cell whether it is the largest in its row and the smallest in the column. Right, sorry, the smallest in the row and the largest in the column. If it is, then you are returning that value. Otherwise, what we did is the optimal one is we stored the smallest in row and largest in column. And every time when we are visiting any particular value, we try to check whether it is smallest in the row and the largest in the column, right? If it is equal, then we say, okay, this is the result, otherwise not, right? We reduce this complexity to order 1. So the final complexity is n square, right? Earlier we were doing this operation in order n. So the final complexity was n cube, right? So here we traded time and space, same example that I tell you, right? That if you feel like stuck, that you cannot improve time without thinking something out of the box, one solution might be by using space. If you use space, you might get a better time because you can like space is always traded with time. You can trade time with space. If you start using additional space, your time might decrease. Okay, it is might decrease, not always key. You can keep on trading time with space. If you use it, if you have infinite space, you cannot reduce the time beyond a point, even if you use space. Okay. Okay. Next was diagonal traversal, right? So every diagonal is would follow some rule, right? That I gave you, that there would be some rule that every diagonal follows, like I minus j equals to 2, I minus j equals to 3, j minus I minus j equals to 4, and so on, right? So every diagonal would follow some rule, and that rule is basically that's the, and using that you can traverse the diagonal, right? Okay, I gave you optimized code how you can traverse a diagonal in order n square. This was like order n cube, right? That logic that we wrote over here. This is the n cube logic. I give you a n square better logic, right? Where you can start with a particular row column and you just visit the values in that particular diagonal. So sliding window and two-pointer concept that are shown in the fourth module, I gave you like glimpse of it, what it is. Now the concept why it is same, just that you will be seeing more complicated and difficult questions using sliding window and two-pointer in the later module. Okay. So there are a lot of questions which are very tricky to figure out whether they belong to sliding window or two-pointer. There is a solution using two-pointer or sliding window for them. Concept wise, we understood it, right? For sliding window is just that you take a size of array, you keep on shifting it, right? And you get some solution, that is your final solution. Two-pointer is same, you take 2 pointers and you keep on shifting those 2 pointers and you get the solution. Now the question level may become very difficult. For example, you can have a sliding window concept on string of arrays, right? Or a string, or you might have a two-pointer concept on string. So all those kind of complicated questions we have not done till now, right? So palindrome is one example, right? I told you 3 different ways to figure out palindrome, and there is different use case of all of them, right? It's just not like different ways and to use. There is a time implication that if we use one of the ways, the time might decrease, right? So same way, there is a lot of places where this will decrease your time as compared to any other logic. So there are questions so that you will solve in 4th module. Okay, till that time we'll get a very good grasp on like arrays, strings, pointers, right? So array strings, array list, so that hash maps. So there is questions like where you can use 2 pointers hash map or a sliding window hash map, which would result in a very optimal solution. And these kind of questions are asked actually. One reverse, 1 2 pointer, third one. Even odd, yes. One reverse, one 2-pointer, and the third one was even odd. You can start with even odd places values. Yes. DSA2, I think I'll cover that part. What is going to be a next module? What are things that you can keep in mind? Okay. Okay, then we did spiral traversal. Now I guess all of them are questions. Then we saw string. String is nothing but you can think it like arrays, just that it has some additional functions that you can use. And there is one important thing: string concatenation is a very expensive operation. So this is the order n operation. Now all the other string functions can be implemented because they are not difficult. I showed you examples like how can you implement equals, how can you implement substring function, how can you implement index of, or how can you implement last index of, right? So all the functions I gave you, similarly, you can implement any string function. That is nothing like, apart from caret or length, there is no other function that you cannot implement, right? Now strings we solved recently, so I guess it is fresh, that we solved a lot of questions on string. So you can use string function. There is a string builder that you can use, which will optimize your time, right? So for example, string builder optimizes your time since the function's complexity reduces there, because concatenation is O1 there at the end. If you want to append at the end, that is O1. And string builder again follows the same logic of array list, right? So it is like a array list for strings. These are all the functions that you might need or you might use. And I told you, right, how can you implement them all? So these are the only two functions that you need to know. Apart from this, all the other functions, even if you forget it, you should be able to implement it by your own. You should not face issues. Okay. But you can remember few ones like equals or substring is something which I always say you should always implement it by yourself, because you always get a better complexity writing it yourself instead of using this. Compare to is something which you can use, but still I showed you how can you compare it. What does lexicographical order of strings mean? It is simply the dictionary order. How can you write a like comparison logic for finding out the compare to function? What is sorting, right? Finally, we learned about sorting. So sorting is basically sorting arrays. There is like multiple ways. We learned about counting sort, right, where we are simply counting and sorting it, also known as bucket sort. We saw about selection sort, where we are like selecting an element, putting it into its correct position, right? Bubble sort, where we are swapping two consecutive elements. And then we finally learned about insertion sort, which is basically the best n square sorting algorithm, because in best case it is order n, right? And this here you perform the least number of swaps in case there is no swaps required, right? Okay. Selection, I also told you what's the like scenarios where you can use it. So selection sort can be used in situations like where you want to just sort the first n numbers of the array and so on, right? Bubble sort can be used in situation like where you know if there are only 5, 7 or some numbers out of order, so you can swap it. It will require the least number of iterations. It will break in between. It is the only swapping algorithm logic, like sorting logic, that breaks in between. This doesn't break in between. Selection sort in all the cases will go for n square. You cannot check in between whether the array was sorted or not, right? Now, in case of insertion sort, what we did was for partial sorting, insertion sort is best. For sorting where you want to break in between, you just know there are few elements that might be out of order, bubble sort is best. And if you don't know any context about the data, using insertion sort is best in case you want to perform an n square logic. You have n log n logic that you'll learn in the later module, right? Yeah. So what we are doing in insertion sort, we assume that the array is initially sorted, which is of size 1. Okay. And then what we do is we take this, we take the next number, we try to check whether it is sorted. Yes. We take the next number, whether it is sorted. Yes. If it is sorted, then we don't do anything. If it is sorted, we don't do anything. Now we say 3, which is not sorted. So what we do in this situation, we I is over here, we take j over here. Now what we do is we compare these two numbers. We'll compare I with j, or this we call as current. We store this into current and we compare current with this. Current is greater than this, so we swap, right? So 10 comes over here. That's it. Next we decrease. We compare 3 with 6. It's still greater, so we bring 6 over here. We just move it to 1, right? We move j to j plus 1. We decrease j. Next we compare 3 with 3. So now it is not greater. We come out of this loop. Now, once we come out, we put at index j plus 1, the value 3, right? So now see this 3 actually got into its correct position. We shifted 6 and 10 by 1, and the other numbers are in the correct position. Okay. So we actually brought 3 into its correct position by shifting other numbers to the right by 1. Understood? Yes, no? So this is what insertion sort is, right? And I gave you one example. You can use deck of your cards, or if you can get a sheet of paper where you can list out numbers and you can practice this. That will give you the best practice of sorting algorithms, right? Okay. Now after this, we learned about, right, how can you merge two sorted arrays, right? So that can be n plus m order, right? How can you merge two sorted arrays, right? In order n plus m, you can do it by merging both of them and then applying sorting, which is n plus m log m. Log n plus m, but you can actually merge them in the order in which they are sorted, right? I gave you logic by comparing two pointers. Again, two pointer approach by merging two sorted arrays. This is again used in things like merge sort or heap sort or something like that. It looks like you can think it like cadence, but yeah, actually we are taking two pointers and we are comparing them, and we are if one of the array exhausts, we put the remaining other arrays values as it is, right? Can you do palindrome using bucket? Is there any way, Sandhya? I don't know. Palindrome using bucket. So bucket is for sorting, right? So how will palindrome be used? I don't think there is any way to do that using that way. Okay. Then we have functions like parse, which is to convert a string to integer, string to double. So basically parse converts any function. So integer dot parse and converts it into integer, double dot parse double converts it into double, and so on. Right. We learned about a even or sort, which is brick sort. Right now you don't see any advantage. This is like your simple bubble sort, which just broke it into two loops, even and odd loops. Right. This is like for parallel processing. You might be able to run both of these loops in the same time, and you'll get the like a better complexity. If you pass it by yourself, you get the same complexity as you get it from here, right? So there is no advantage. Right. So that's the same order and complexity that you would get. I guess I'd say you would get the same thing, right? So it doesn't matter. You would get the same thing anyways. It is outputting, right? Yeah. So you get the same thing that you get from here. Lastly, we learned about stream reader and buffered reader. So basically, these are advanced ways to taking input. The scanner works fine, but this is for like using stream reader. Using buffered reader, you can read input from file, input stream like mouse click or audio or video or something like that, right? So you can have advanced input. So right now we saw one example where we are reading stream of input from this console, which is again string, and we can convert it into any type like boolean, integer, double, and so on, right? That's it. Then we learned about string builder, which is like a array list of strings. You can create it of any like you can create a string builder. Just the advantage you get it is created in the heap of the memory, and it has some additional buffer space at the end, so you can perform append operation in O1 time. Right? Like if it exceeds that buffer space, if you like exceed the if you have put input in characters in all the empty spaces, it will double up the space or do some logic like array list, which will give you again O1 complexity, right? So average complexity to perform this is O1. Now this is very advantage. Now using this, the complexity to find out substring, complexity to perform string concatenation, and all such logic reduces, right? So it reduces the logic complexity, right? So we solved then questions like triplet sum, AJ numbers, right? So all the advanced questions we solved yesterday, and that's it, right? Today we learned about sieve of Aristotelian. Can we give a default capacity? I don't think so. There is a way but there is a way to increase capacity. I guess there is a function known as increase capacity or something, which using which you can increase the capacity. But I don't think that you can give a default capacity like that. You can increase it a capacity to a certain thing if you want. There might be argument that you can pass as the second or third argument, which would be like over here, which you can take the thing. You can validate this, right? Whether you can pass second or third argument as the capacity of this. There might be ways you can override the default. There should be ways to override the default capacity either by passing this, or you have the function to increase capacity, right? So using that you can do it. Okay, so this is what we learned in this module, right? So which is like the basics of programming. Now, firstly, tell me how many of you got the idea for arrow function? How many of you got the idea of basics, right? Now, this is what your basics of programming looks like. Now, like till today, you might have seen code, right? Some random code written. but after learning it, right, in an organized way, now I guess every code would make some sense to you, right? You would be able to figure out how kuch to kara hai, something like this. It has created a string or created a loop or something. I even showed you an actual code, right, where it was taking input from a camera or something, and there we were able to make out, right, that this was an array, this is a loop, this is a string, right? What it is doing, we got some idea at least, right? So that's what you will get for now, right? You can start building logic. You can practice the remaining days from the gym section. I'll give you idea what your next module is going to look like. What are the things that you can take forward from here? So see, your fundamentals of things are not going to be covered again. Like for example, loops, conditionals, switch cases, or like nested loops or nested conditionals or basics of arrays or 2D arrays. These are covered till here, right? So we would expect that you all be good on these parts at least. Okay. So your interviews, your exams should also be focused on this part so that we evaluate it in the correct way, that you have cleared the module honestly and you have learned something from the module, right? See, for those of you who have learned, you feel confident, you feel comfortable, you have done ample amount of gym questions, you practice it hard, and you feel that I have learned it in one go and I have understood everything, and you want to go to the module 2, that's fine. For those of you, if any one of you who is feeling like, I know that few of you are working professional, you might not have got ample amount of time to practice it or to understand each concept in depth, right? You might have got like a priority project or priority delivery in 10-15 days. So you might not have got time. That's completely understandable. Just talk to your batch manager. I'd say if you have doubts, don't feel like ashamed, don't feel like my 1 month is going to get wasted in learning this. Trust me, your month is not going to get wasted, right? So like your month is not going to get wasted. You will learn a lot. Even if you repeat it, you will learn a lot, right? So don't hesitate if you feel doubts, if you feel like I am not confident, I have not learned things, I want still more time to practice arrays, array list, strings, I want to get better clarity on this or solve more questions so that I feel confident on going. I have a lot of assignment questions that I have not solved myself. I have like I do not get time or whatever is the reason. So that's completely fine. Just talk to your batch manager. Take a do that so that you see, ultimate goal should be to develop skills. You might get your job might get delayed for a month or two, right? And that's the thing that is going to happen, but you will be better prepared for the jobs, right? Whenever it comes, you'll be better prepared, right? You will be prepared for better opportunities. The companies are going to pay you. They are going to pay you very well, right? The software engineers honestly gets paid like the best salary in the industry, right? Compared to any other profession, if you check, right, software engineers are highly paid. Now why software engineers are highly paid? Why do software engineers have salaries in crores, and why don't any other profession has this? Because you are not replaceable, right? These concepts are difficult to learn and difficult to master, right? It is very difficult to find out a replacement for a software engineer as compared to a salesperson or a marketing person, right? Because this is very technical knowledge, and technical skills are takes time to develop, and it takes efforts to develop. It is patientful skill, right? Lot of students, lot of people give up learning the skills. So even if you require a little bit more additional time, that's fine. Like it's going to ultimately benefit you a lot in your career if you have these skills, right? If you have this knowledge, if you have this problem solving ability, uh, today 5 years 10 years down the line, you are going to be basically a better engineer as compared to like if you just ignore this fundamentals, right? This fundamentals needs to be strong. Okay, so focus on that, solve more assignments, solve gym questions, still have doubts, use the doubt session, every other thing is there, right? If you still feel that I did not get time, right? Last module I got a like query, like one student was he was doing very good in the module, right? He was performing well, and then he got a priority project. He was working on, I guess he's working on Wipro. He got a priority project, so he had to like work on that, right? You cannot tell no to your job, right? So he had to work on that. So he asked me, sir, I am like not getting ample amount of time. I was doing too good in the first 10-15 days, but now I'm not getting time, right? So what should I do? I simply told him that like practice at your own pace, right? If you get time, if you're practicing, that's fine. At the end of the module, talk to me. If you feel like you want to repeat to learn it, that's completely okay. If you feel like that I have learned, I have got a good grasp of module and I want to proceed, you can go to the next module, right? Later, when he ended the module, he understood the first parts very fine. Later part, he did not get time. he repeated it, and then he performed very well in the next again when he did, and he himself told that it was a good decision to repeat it, right? So don't hesitate if you fill out, but I would say, yeah, practice very hard so that you clear it in one go. That should be your goal. But if you get a backlog, just learn it, right? Your focus should be developing skill, and at the end, that's going to matter. Learn it. Use your time to learn it in interviews. There is no way to cheat, right? There is no way to fool an interviewer around, right? I or any other person who is working on this domain, he can within 15 minutes of the interview figure out how much technical knowledge you have on programming. Okay, the way you would write code, the way you will explain a code, that will immediately be able to show how much coding you know. And there is no way to bypass interviews, right? You can bypass technical test, you can bypass online rounds where you have, where you can like take help from others, where you can not learn by yourself. But there is no way to bypass an interview, right? There is literally no life hack that you can use there. So you need to learn these things. If you want time, you want support, you want help, we are there. Use it. All the concepts that we learned in this module are going to be used in the next and the next to next modules. Now, in the next module, what's going to be there? You are going to learn recursion, you are going to learn linked list, you are going to learn stack, and you are going to learn queue. All of them, all the 4 topics, recursion, linked list, stack, and queues, are fundamentally very important topics, right? Linked list will tell you even a lot about your memory management that we did right now, like arrays or by variables or by array list. Linked list will show you how you can use that memory to your advantage. How can you create flexible size arrays, something like that. What are the drawbacks of it with the traditional arrays that we have, right? There is no way to actually cheat in interviews, right? See, so people cheat in online rounds. That's honestly, I'll tell you. But in interviews, there is no way to cheat. You will never see anyone clearing interviews by cheating. There is no way to get around clearing an interview, right? So for example, interviewers are very cunning, right? They check the, like, they immediately be able to know, right, whether you know the concept or you're looking at somewhere or you're explaining it, right? So for example, if they ask you a logic, okay, so let's say how would it go if an interviewer asks you a logic which you don't know, CO based or something like that, right? Some logic that you want to implement or something, let's say cadence or something like that. So if you have never seen a logic like that, and 90% of the time the code that you get in it to write in interviews is completely new or might be completely different, or a variation of the question that you have solved. So you have to start thinking from scratch, and then you gradually approach to the solution, right? So that process is something which interviewer sees. If you write a code and you are not able to explain, interviewer will be able to know that you wrote it from somewhere else, right? You just googled the question, you got it, the solution, you wrote the code. So that's immediately explains to the interviewer, right? So there is tons of ways to figure out. There is, like, practically speaking, there is very no way to actually bypass those interviews. And there is not even only one round, there are multiple rounds, right? You might get lucky in one of the rounds, but what about the other rounds, right? So your technical skills are required, knowledge is required, right, to clear them. And see, to even on work, right, even if you get that job, right? So let's say sales, or you got a sales or marketing job. So even if you have not done MBA, or even if you have not done any kind of commerce degree, will you not be able to figure out how to sell a product? Will you not be able to figure out how to do a little bit of marketing of a product? That is something you can figure out. But if you don't know programming, and I keep and I hire you as an engineer, will you be able to write the code? Will you be able to figure out how to write code? Probably not, right? So software engineering is such a thing where you need to know the skills beforehand or before getting the job, because you can't figure the things out in the job. You can learn things. I can give you a new technology to work on, but if you don't know programming, you won't be able to figure that out, right? Yeah. Okay. So you will keep on learning. This is like a ever learning thing, right? The learning in software engineering is so vast that everyone learns, right? So we keep on learning every day, right? So you will learn every day in your something new. So that's fine. When we learn about OOPS concept, I guess that's in module 3 or module 2 hoga. Module earlier it was module 3. It's module 2, TK. So that's in module 2. So OOPS, recursion, linked list, stack, queue. So I guess these are the things that's there in module 2. Okay. और 3 में you have things like advanced ESA, or you have yeah. अच्छा शिवा on this अच्छा lead code one. अच्छा let's discuss this one Pita. अच्छा this one we did not discuss this time, right? ठीक है. Eden, Buron and Goran were like 3 bird lovers. They wanted to know the applicants have passed the exam. ठीक है. So see, they are like all of the 3. There are 3 students. They have figured out their sequence, right? So these are the sequence that they have figured out of what's the correct answer, what they are going to do, right? Now you have to tell which of these 3 among these 3 students are going to get the highest score. And if they, all of them get the same score, like which is the highest one, print the name of all of the 3, right? So you just have to do check. See, if the first this is B, you just have to check what is the first solution that this is Arden is going to mark, what is the first solution Bruno is going to mark, or what's the first solution Goran is going to mark, right? Whichever ones matches, you just need to take 3 variable, count the number of solutions for each one of them. So what is the repetition for this? So Arden is going to repeat ABC. So you just have to repeat ABC. You take a string like ABC. Acha. So for Arden, the string is ABC. For Bruno, the string is BABC. For Goran, the string is CCAABB. Okay. Now you just need to do %3 to get what's the result you want to get. So for example, you want to get let's say a string. This is the correct result. Okay. And let's say for this particular index, which is 0, 1, 2, 3, 4, 5. 7. So this is the 7th index. At 7th index, what all of them would have marked, right? So at 7th index, just you do %3. That %3 are going to get 7%3 is 1. So Arden is going to mark B. 4%, 7% is 4 is 3. So 0, 1, 2, 3. So Bruno is going to mark C, and Goran is going to mark 7% is 6, which is 1. So Goran is going to mark C. That's it. Okay, so you just have to do %3, %4, and %6. That will tell you what each of them is going to mark. Whatever index you get out of this, just check for that index value that each of them is going to mark this. Which whoever one marks correct. So this is Arden is marking wrong, Bruno is marking correct, and Goran is marking correct. So just increment Bruno and Goran by 1 and Arden by 0. Understood? Array size 3 and string of size 3. Tell me which one should take less space. I taught you about space. Now tell me which one should be taking less space. Both of them take the equal size space, right? String character array 3 size takes 6 bytes. String of 3 size takes 6 bytes, right? So both of them takes equal size of space. In Java, it is not different, but in C++, it is different because string takes 1 additional byte, 2 bytes extra. Both 2 bytes character, right? So both are 2 bytes character, so size is going to be same. So in Java, it is same. In language like C++, where they like string is stuffed with 1 additional character at the end, it would take 2 extra bytes. So let's see. Partition equals subset sum. So this is a subset question. It would require hashing DP, right? So this is marked as DP, right? So this is something you should not solve now, right? This is a dynamic programming question. So I told you, right? Subset and subsequence problems are dynamic programming and hash set questions. So you don't need to solve them now. Okay, that is there later. This just check the tags. It is also marked as along with array. It is marked as TP. Okay.
Sir.
Yes.
एक क्वेश्चन था सर.
हाँ.
एरे में मतलब जो एरे होता है ना उसमें मैक्स फाइंड करना है, बट वो एरे जब देना है ना तब वो साइज नहीं दिए तो वो मतलब विदाउट साइज का एरे में एंटर करके उसका मैक्स लेना है.
Without array
मैक्स
का
निकालना
कुछ तो इन्फॉर्मेशन दिया होगा, right? Till when will
हाँ
take in input?
वो सिर्फ इतना दिया है कि n साइज मतलब n मतलब जो n साइज ऑफ एरे मतलब साइज ऑफ एरे नहीं दिया है, सिर्फ n इंटीजर्स हो गया ऐसा कुछ दिया है।
So n integers तो size of array होगा ना, विदाउट साइज हम इनपुट ही कैसे लेंगे, राइट? सो सी लाइक तो अगर हम इनपुट ले रहे हैं, राइट, तो इस इनपुट को लेने के लिए हमें पहले से ही बताना होता है ना हम कितने बार लूप रन करना चाहते हैं। अगर हम कितने भी इंटीजर हैं, कुछ तो कंडीशन होगा, लास्ट वैल्यू 100 होगी या लास्ट वैल्यू -1 होगी, तब ब्रेक कर दो और उसके बाद इनपुट मत लो। तो जो भी कंडीशन दिया होगा, लास्ट वैल्यू के ऊपर कंडीशन दिया होगी, या तो साइज दिया होगा इतने नंबर ऑफ इंटीजर्स है, राइट? तो वही है।
साइज तो नहीं है, बट ऐसी कोई कंडीशन मतलब अगर कोई मतलब ऐसा कोई कंडीशन है जो अपने आप ही
हाँ, ऐसा
टर्मिनेट
कोई
हो जाए,
कंडीशन हो
मतलब
सकता
अगर
है, ऐसे बोल दिया जाए कि सारे जब तक एक नेगेटिव नंबर नहीं मिल जाता तब तक इनपुट लो। तो हम ऐसे कर सकते हैं ना, वाइल आई इज
हाँ वो राइट,
वाइल
उस
एन
टाइम पे
इज
मतलब
ग्रेटर देन
कंडीशन।
0, वो उसको
तो इस
कंडीशन।
क्वेश्चन सर ये वाला क्वेश्चन हमने चैट में पेस्ट कर दिया है इनको सीधा।
हाँ ठीक है, सो देन यू कैन कीप ऑन टेकिंग इनपुट, दैट्स फाइन। ठीक है।
यस,
okay,
वैसे मैंने वो एरे लिस्ट से भी ट्राई किया, बट वो एक ही बार इनपुट ले रहा है।
okay, so you have written the solution to this one, इसका सॉल्यूशन लिखा है। why there is so many edge cases, यहाँ पे इतने सारे edge cases थे क्या? I don't think इतने सारे edge cases हैं यहाँ पे। So let me write this logic, right? ये तो छोटा सा logic, I'll take 5 minutes. I'll explain this. ठीक है? So this one we discussed yesterday, right? So longest mountain array. ठीक है? So let's take let's simply run a loop for starting to end, and what I told you that for every loop index start by 2 values, like start and end. Start is equals to I minus 1 and end is equals to I plus 1. ठीक है? And what we'll do is until we'll keep on running this loop until start is greater than equals to 0 and end is less than n, right? If this condition is true, we'll keep on running this. We can take a maximum, that is the maximum length, which is 1, right? So one size, we can have one size mountain, that is always fine. That is the minimum size that we'll get. We should get 0, no mountain in the array. Achha, so it should be at least 3 size, it has mentioned, right? At least 3 bola hai. At least 3 bola hai, right? So it is 0. ठीक है, चलो, let's take 0. Now we'll check, right? If so what's the value that we have? So let's take previous previous start is equals to a of I, previous end is equals to a of I, right? So in both the cases it is a of I. So what we should be getting it in towards the left, it should be decreasing, right? So if the a of start is less than a of end, so this is the mountain, right? So if a of start is less than a of end, sorry, a is less than ps, it should not be even equal to, right? Equal to भी नहीं होना चाहिए. Increase after it, decrease after it. It should not be equal, it should be this situation, right? So if it is less and the a of end, so at the end wise, end side is also less, right? So the ps of this is greater than this, right? So ps is greater than both start and end, then what we can do is, okay, ps of end. Then what we can do is we can simply do start, we can simply store ps is equals to a of start. This is the previous end, ps p is equals to a of end. Start minus minus and plus plus, right? If this is not the situation, else if this is not true, else we can break, we don't need to do anything. Finally, whenever we break, so this is condition is false, then we should at here we'll find out the max, right? So if let's find out the size in the distance is equals to the end minus start. So let's say we get 4. So this is less, this is not satisfied, so we break. So end minus start is going to give us 3, where it is actually 2. So it will do -2. I guess this is it. Is equals to math Let's check for this one. We should get 5. Hmm. 0, 1, 2, 3, 4, 5, 4, 2. We're getting 4. Acha, we are including that as well, right? This book -1 over, right? Okay. Okay. So you are talking about this case.
There is one thing like if we decrease both start and ed, so if we take 5 as middle one, here mountain up to 2, it is like we'll get to 3, like left side, but still we have left side mountain that up to 0, right?
I did not get to. For in this particular example, what is happening is, so what should be the output? Like 1, 2, 3, 4, 5, 6, 7, 8, right? 8 numbers. So which is the middle element? We are
5. Let's
5
take
is
5 as a middle element. So right side it goes up to 2, fine, but left side it can go up to 0.
sir,
Right?
it is telling that the mountain can be unbalanced as well. Is
Yes,
that
yes.
similar? Oh,
Yeah,
okay.
it can be left and right unbalanced.
Okay, okay, it can be left and right unbalanced.
Yes.
Okay, so then we just need to break this into 2 conditions, right? That's it. So if we can just so if this is the situation, then we can just put this over here, right? So if this is true, then we'll do this. I thought it was balanced. Okay. If this is not the situation, then we check else if a of, so we'll first decrease the start, then we'll increase the end. So else if a of end is, so else if ps is p end is greater than a of n, right? This is less, then we can do p end is equals to a of n and n plus plus. Now if I run this, we get 6, which is fine, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay, we should be getting 8, you're telling, right? We should be getting all.
Yes.
So let's check. So for this particular situation, we started with this start -1. So this we decrease. We'll keep on decreasing, start becomes 0. Okay, so we can break it into 2 loops. Okay, if this is the situation, if start is equal to, if start becomes negative, right? If start is equals to -1 and we break, then we have to just simply consider it 0. Otherwise it's start. And in this is like going to be the another case of while loop, while n is less than n, and we do this if condition, else break, and then we copy this else break to here as well. And we write the same thing for end. End is equals to n greater than n less than n. Question mark. If it is less than n, then fine. Achha, if it is equals to n and we have broken, then we can put it n -1. Otherwise, we can put it as n. If I run this, we'll get 6. Why? So let's check. Let's check over there. What we are doing is, let's say we started with 0. If we checked what's the next smaller number to this, no smaller number. 1, We check for next. Let's check for 5, right? When I is equals to 5, what we are doing. So we started with I minus 1. We checked is I. So is this greater than 0? Yes. Is the index greater than equals to 0? Yes. Yes. A of start less than the previous value. So is 4 less than 5? Yes, it is 4 less than 5. So we okay. Let's check what's the expected output for this one. 8. Okay. So we check 4 less than 5. It is fine. So we decrease start. We check we check 3 less than 4. It's fine. We decrease start. We check 2 less than 5. It's fine. We decrease start. We check 1 less than 5. It's fine. We decrease start. We check 0 less than 1. It's fine. We decrease start. And then finally, start becomes negative. So if start is negative, start is minus 1, right? Then we put 0 instead of it. That this is the starting index. Okay. Now at end, what we do at end. So in the case of end, what we are doing is if it is otherwise 0, otherwise whatever start index is, we can just do +1. On here we can simply do -1. Whatever end is. End -1 ही कर सकते हैं in general terms, even if it has ended, and here even if it has this, check भी नहीं करनी है, start +1 and end minus start +1 something this. So I guess ये simple है. This would work. Yes, now we get 8. Now if I run this, should be fine. Yeah. See, I'll explain what we did over here. See. So it's simple, right? So just that it is the angle can be unbalanced, right? So for that, I just considered 2 loops, right? So one is we'll find out the starting index, one is we'll find out the ending index. Okay. So let's say we are considering any particular number, right? So let's say we are considering 5. Okay. We'll consider it for every number. What we are doing is we are checking until start is greater than 0. We'll just compare this number with 5. Previous start is A of 5. So we start with previous start is A of 5, which is the number which is our center. We check is the new start, like we decrease the start, is this less than is previous start? Yes, it is. So we store this as the previous start and we decrease start. So next iteration we'll compare 3 with 4. Next iteration will compare 2 with 3. Next iteration will compare 1 with 2, and next iteration will compare 0 with 1. Okay. So we'll compare this and finally we'll get the start. So whatever start we'll get, right? So that will always be 1 less. So here if it will satisfy this, it will become -1. We just have to move it to the start, which is the start +1. After this loop, if you just do start +1, it will move to its correct question, which should be the start of the mountain, right? So consider, like for example, यहाँ पे 10 होता. So our start would have ended over here at index 0. But what is the actual start of our mountain? Ended index 1, right? So if you consider 5 as the center, this would should have ended over here. So that way start +1. Okay. Now if it ends at -1, it will become simply 0. Same goes for end, but here we are increasing end. We are simply moving towards right. We are comparing these two. If like the previous end is greater than this, okay, then we store this as previous end, and we increase this end. Then we compare 4 with 2, okay, and then finally end becomes n. So we just decrease it by 1, so that n becomes like equal to the index where it should have ended. So for example, if it is 12, our end will end over here. So simply bring it over. Now let's say we have to count all these values. So let's say यहाँ 10 है, यहाँ 12 है. So we have to count these values. How many values do you have? So from end to start, how many values do you have, including both end and start? It is end minus start +1. Right. So these are the values. This is the distance that you have. You just find out the maximum of it. You get the maximum. You return it. Done. That's it.
Got it. Like, but where are we checking regarding like the length should be minimum of 3?
Minimum of 3. So we are starting with here. See, so our max is 0, right? So our end and start always starts with like this index, right? I minus 1, I plus 1, right? So if this condition would satisfy, if this doesn't satisfy, we don't decrease it, we break. So and we do start +1, so start will become I and this will become I. This is a problem. So we do okay. So I minus I plus 1. So which is 1, so it would get 1, right. So you I guess that is a missing test case over here. So for example, let's say this situation, right? I don't think there is any test case, but for example, a situation like this where this condition never satisfies. Consider an array like this: 50, 40, 30, 20, 10, 5, 4, 3, something like this. Okay, so there is in both the conditions will never satisfy, right? Both the conditions, no, this would set. Oh, this is a decreasing array, right? This is having a decreasing array. So I guess you won't be able to create an array like this.
Once, okay, like there is a similar question on lead code, same question. If I think in lead code we can have that edge case.
I guess you can simply check this, right? You can simply check this if max is equals to, if max is less than 3, less than or equals to less than 3, simply return 0, otherwise return 1, return max, right?
Yeah, this.
The simple check. I think it will take care of. There might be some edge case which might fail, which might not have been covered over here, but okay. Max you find here because the question is asked to print the maximum length of that. What can be the maximum mountain? So, for example, you can find multiple mountains. This is a mountain. Right? This is a valid mountain. No, sorry, this is not a valid. This is a valid mountain, right? But it has asked to print you the maximum length. So this is the maximum length. So what we did, simply decreased it toward the start, simply increased it toward the end, and then finally we told, okay, this is the start index. By increasing it by 1, ending index and decreased by 1. This is the distance, and we find out the max. Okay. So 3 वाला question में बताया गया है कि the length should be at least 3. It should not have greater than 3. So what we did was we simply checked if it is less than 3, just store 0, otherwise 1, otherwise the maximum. Okay. So I'm taking one last question, and then the remaining ones you can utilize the doubt sessions for it. Count and say. So ये तो easy mark, इसमें क्या दिक्कत है? There are n, find the nth term in the count and say sequence. The count and say sequence is a sequence of below integers like this. Okay. The nth term of the series generated by the n-1th term. So how is it generated? 1, 1, 1, 2, 1. How is it generated? Anything that you see similar? 1, 1 add kara hai isme.
Like it is like first one is 1 and there are 1 ones, 2 ones.
2 1s. Then third term is 2 1 generated by reading. Second term 2 1. Acha, 2 1. Fourth term is generated by reading 2 1. So 2 the third term is generated by reading 2 1. So third, this will be at 2 1. So generated by reading the second term. So it's generated by reading the third term 1 2 1 1. Acha, 1 2 and 1 1. Acha, it is 1, so it is read as 1 1. This is read as 2 1. This is read as 1 2 1 1. This is read as 1 1 2 1. 1 1 1 2 2 1. Acha, nice.
Sir, counting its previous one frequency.
हाँ, प्रीवियस वाले की फ्रीक्वेंसी को काउंट करके मिल जाएगा, राइट? प्रीवियस वाले की फ्रीक्वेंसी को काउंट करके मिल जाएगा, वही आइडिया आई गेस. सो सी, it is 1, so previous one's frequency is 1, so you generate the 1 1. ठीक है. Now here one's frequency is 2, so you write the frequency first and then write the number. ठीक है. So you get 2 1. Now what's the frequency of 2? So your frequency of 2 is 1, so you write 1, then the number. Frequency of 1 is 1, so you write the number. ठीक है. Now this number, frequency of 1 is 1, then write the number. Frequency of 2 is 1, write the number. Sorry, write the number. Frequency of 1 is 2, write the number. So this is the next number. Now write this. Frequency of 1 is so frequency of 1, sorry, frequency of 1 is 3, and the number is 1. Frequency of 2 is 2, and the number is 2. Frequency of 1 is 1 and 1. Got it? पहले frequency लिखना है, then number लिखना है. If the numbers are same, then you count the frequency until you get a next number which is different. Then it is same, you count on the frequency, you get the print the frequency and then the number, then you get the frequency. Yes, a compressed string. Yes, that's the same question. Compressed string में जो logic बताया था वही same use करना है यहाँ पे. Okay. चलो. Okay. Rest all questions, solve it, use the doubt sessions. You have 3 days, 4 days till your final module test. Practice a lot, practice a lot of gym questions, practice a lot of questions. Use the doubt sessions, all the forums that you have. All the best for your exams. I know you all will do good, and I'll see you all in the module 2. Okay. So it was great. Like you all are doing very good. Keep that up, right? Don't let your spirits go down. Keep on practicing with the same energy for 4 to 5 months, and probably we'll see you with very good job offers. Okay. So thank you everyone. Have a great day. Right. Too great. Okay, chalo. For now we are with the doubt sessions, right? We'll probably meet again, right? So we have a long journey, right? So we have 6-7 months journey. So hopefully we'll meet again in some other module, right? For sure. Thank you everyone for now. See you all again. Bye bye. Good night. Take care. Thank you.